I'll request everyone to please keep a bit of silence and make sure your phone is on. One and all present over here. I, Ayush Vaidyam, and I, Harvard Kaur, extend a warm welcome to all the distinguished guests, esteemed faculty members, and participants at Generative Institute of Engineering and Technology, Nagpur, for Faculty Development Program on Generative AI and Application, organized by Department of Artificial Intelligence, sponsored by AICTE Teaching and Learning Academy, which marks a significant step forward in fostering innovation, research in the field of AI, and excellence in education. It will embark on a journey of professional growth, knowledge enhancement, and collaborative learning lineup with insightful sessions. Today, we gather for the moment of significance to light the ceremonial lamp on this auspicious occasion for the Faculty Development Program. The ceremonial lighting of this lamp is not just a ritual, but a deep symbolic act. The lamp represents the flame of knowledge that illuminates our minds and disciples the shadow of ignorance. As we proceed with this beautiful tradition, let us keep in mind the symbolic importance of life and its power to guide us through the journey of learning and enlightenment. Now I request all honored dignitaries to come forward and initiate lamp lighting ceremony. Let this act signify the illumination of our path. At this will embark the beginning of ATAL FDP inauguration ceremony. Thank you all.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना शङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीम्.
Now, I invite all the distinguished dignitaries to occupy their seats on the dais.
As we embark on this exciting journey together, we take a moment to express our thankfulness to all our esteemed dignitaries for taking out their valuable time and gracing our inauguration ceremony.
We are privileged to have with us today Mrs. Preeti Ramakrishnan Ma'am, co-founder and COO Immersive AI, as the chief guest for today's inaugural ceremony. May I now request our honorary chair, Dr. Vivek Kapoor sir, to kindly welcome our chief guest, Mrs. Preeti Ramakrishnan Ma'am, with the bouquet. Sir, please. Thank you, sir.
May I now request Co-Coordinator of Faculty Development Program, Dr. Smita Nitli Ma'am, to kindly welcome our honorary chair, Dr. Vivek Kapoor sir, with a bouquet. Thank you, ma'am.
May I request Dr. Sakshi Sadhwani Ma'am to kindly welcome the coordinator of the Faculty Development Program, Dr. Smita Nitli Ma'am, with a bouquet. Thank you, ma'am.
May I now request Professor Tabassum Khan Ma'am to kindly welcome our co-coordinator of the Faculty Development Program, Dr. Sakshi Sadhwani Ma'am, with a bouquet.
For the inaugural ceremony, we also have our first speaker of the FDP, Dr. Nilesh Pikhale sir from IIIT Nagpur. I request Professor Rahul Suryavanshi sir to kindly welcome him with a bouquet. Thank you, sir.
The main objective of ATAL FDP is to plan and help in imparting quality technical education in country and to support technical institutions in fostering research, innovation, and entrepreneurship through training in various emerging areas. Stress upon empowering technical teachers, technicians using information and technical technology.
To utilize SWAYAM platform and other resources for the delivery of training and provide a variety of opportunities for training and exchange of experience, such as workshop, orientations, learning communities, peer mentoring, and other faculty development programs.
To support policymakers for initiating training as per requirements.
The objective of the program is to impart knowledge on the basis, analysis, and application of generative AI. Participation in the program will helpful for young teachers to engage in research work in the field of generative AI and its application. This faculty development program will help faculties to learn various generative AI tools and perform prompt engineering for AI tools. The main motive of FDP is to understand the concepts, methods, technology, and architectural applications. The underlying principle of generation of new content is based on variety of inputs, different generative AI tools, to deploy and develop applications.
With great joy and warmth, we extend a heartfelt welcome to our coordinator of FDP, Dr. Smita Netli ma'am, a beacon of inspiration and a cherished presence among us today. Dr. Smita Netli ma'am, a distinguished scholar, showcasing her expertise in artificial intelligence, data mining, digital forensics, cybersecurity, pattern recognition, deep learning, and machine learning. Recognized as an outstanding woman in engineering and awarded the Best Teacher by Universal Innovators Leadership in 2021. She is a luminary in academia, serving as panel member judge for the Data Science Awards in 2020 and 2021 across 4 categories.
Her expertise is widely acknowledged as the author of Data Mining in Cyber Forensics, a systematic approach. She has contributed significantly to her field. A published researcher with over 50 papers in esteemed journals, she has also excelled as a field reviewer and editorial board member for the reputed journals and IEEE conferences. She is a proud member of CIS, IEEE, IEM, ISV, and the Internet Society. She has secured grants, including an amount of 8 lakh for her groundbreaking research project and an amount of 50,000 from AICTE for organizing an international conference. Her journey is a testament to excellence and commitment in the field of computer science and engineering.
She recently has been recognized as an ethics champion by IEEE Region 10 EAC, and she was IEEE Ambassador for IEEE Day 2023. With this, now I invite coordinator of FDP for a welcome address. Ma'am, please.
Thank you, Ayush and Harman. A very good morning to all of you. Respected chief guest of today's function, respected director sir, deans, heads of various departments, colleagues, and dear participants. It is my privilege to welcome you all to the inauguration of this faculty development program on generative AI and its application, organized by Department of Artificial Intelligence at Raisoni Institute of Engineering and Technology, Nagpur, sponsored by ATAL Academy. The field of AI and generative AI in particular has seen tremendous advances in recent years. Models like GPT-3, DALL-E2, and Stable Diffusion showcase the ability of AI system to generate high-quality text, images, video, and other multimedia content. The open release of these models is transforming what is possible with AI creativity. Through this week-long program, we aim to impart in-depth knowledge to our faculty participants on the latest concept, technique, and application of generative AI. The sessions are designed to provide both theoretical insights as well as hands-on experience working with state-of-the-art generative models. Distinguished speakers from academia and industry will share their expertise over the next few days. I am confident the lecture sessions, hands-on sessions, and assignment discussion will lead to fruitful learning and exchange of ideas. Participants will leave better equipped to pursue research, projects, and teaching in this emerging domain. I would like to express my sincere gratitude to our chief guest, Mrs. Preeti Ramakrishnan ma'am, for taking out time from her busy schedule to be with us today and inaugurate this program. Ma'am, your presence speaks about your commitment and interest in promoting technology education and research. Also my hearty thanks to our chairman, Sri Suniji Raisoni sir, and director, Dr. Vivek Kapoor sir, for their leadership and for encouraging us to organize events like this that contribute to the professional development of faculty members. I take this opportunity to acknowledge the support of AICTE for approving and funding this FDP under ATAL Academy initiatives. Their assistance has enabled us to organize this timely program on an emerging technology topic. I also thank co-coordinator and organizing team for all the effort and in planning the session, coordinating with experts and making the necessary arrangement to ensure smooth conduct. I once again welcome all participants. We have an exciting week ahead filled with learning and exchange of ideas. Let us maximize this opportunity, engage actively, and enrich our understanding of generative AI. Let us have a great week ahead, filled with exploration, upskilling, and inspiring conversations. Thank you, one and all.
With great pleasure, we introduce our beloved director, Dr. Vivek Kapoor sir, and also the honorary chair of the FDP, a person of profound accomplishments and radiant spirit, enriching the canvas of our shared movements. With an extensive 26-year career as a dedicated academic professional, he has excelled in various fields such as strategy planning, project management, and quality assurance within the dynamic landscape of technical institutions. Currently entrusted as a director of Raisoni Institute of Engineering and Technology, Nagpur. His role involves in steering the institution towards a trajectory of excellence, recognized as Margdarshak by All India Council for Technical Education. He has further contributed as an NBA evaluator for the National Board of Accreditation, conducting assessments in over 40 institutions.
Engaging actively in nationwide MBA initiatives, his commitment extends to serving as a NIAC evaluator appointed by the National Assessment and Accreditation Council in Bangalore. Acknowledged by University's Grant Commission in New Delhi, he has been appointed as an expert for Award of Autonomy in Technical Institutions. Passionate about knowledge, he has delivered 20 plus expert talks and conducted over 10 workshops nationwide, guiding institutes in defining their vision, mission, and educational objectives with global perspective gained from the visit to estimate universities worldwide. His involvement in LEC committees and affirmation responsibilities underscores his education to academic development in more institutional and group levels. His multiple contributions shows the commitment to shaping the academic landscapes. With this, I invite Honorary Chair to kindly give address to FDP. Please, sir.
Chief guest of today's function, Preeti Ramakrishnan Madam, co-founder and CEO, Members AI, coordinator of this FDP, Dr. Smita Nelke Madam, Head of Department AI, co-coordinator Dr. Shakshi Sadhwani, Registrar Achal Sahare Sir, Deans, various Deans, Head of Departments, faculty members, and my dear all the participants. On my personal behalf and on behalf of GH Raisoni Institute of Engineering and Technology, I welcome you all in this inaugural function of AICT sponsored ATAL FDP on generative AI and its applications. It is both an honor and a privilege for me to stand before you all today and to welcome you all in this learned community. I heartiest congratulate Dr. Smita Nelke Madam and her entire team for taking efforts and working since last so many days to make this event a grand success. And also I would like to congratulate the entire department for organizing this ATAL MDP starting from today till 10th. As a faculty in and particularly I'm talking about the teaching domain, to survive is a difficult task as far as today's latest trends, technology changes are concerned. Every day there is some new technology in the market. Few days back in the same hall for the same inaugural program of one of the students training program, I shared them with one story of Nokia. I hope everyone was aware about Nokia long back, 10, 12 years back. Nokia was one of the leading mobile company across the world. And just because they are not ready to upgrade themselves or to accept Android platform, they were out of market across the world. And at the same time, many other companies like Samsung, LG, Motorola, many more, they came with the Android model version or platform. And they are one of the leading brands in today's scenario. And finally, few years back, 2-3 years back, Finally, Nokia has taken Android version platform on for their mobile segment. So try to understand the upgradation or updation of ourselves. It's need to upgrade ourselves for our own survival with the latest rapidly changes occurs in various technologies, trends adopted by the industry across the world. And if you want to become a successful teacher or a faculty in any of the industry, any of the domain I am talking about, it's not related to the education industry, but it's related to the industry also. So if we wish to survive, if we wish to achieve high goals, attain high height, it's possible only when you ready to accept the changes as per the today's scenario. And I guess, or I believe personally, attending such kind of faculty development program, training programs is one of the media or the platform for our upgradation. So I guess next coming 5 days from today to 10, all the participants will attend entire sessions with most sincerely and dedicatedly. And I believe at the end, every faculty will go with a richer knowledge base as far as artificial domain and its various applications are concerned. With this, I once again congratulate AI department and extend my best wishes to each and everyone for this upcoming 5 days learning programs. And wish you all the best. I guess or I hope that these 5 days will be the most best days of your life in terms of gaining the knowledge, in terms of hospitality, in terms of all the aspects of faculty development training programs. So I extend my best wishes for the grand success of this activity. Thank you very much.
Sir,
With immense pleasure, we extend a heartfelt welcome to the chief guest of today's program, Mrs. Preeti Ramakrishnan ma'am, whose presence adds a touch of brilliance to our everyday.
Mrs. Preeti Ramakrishna worked in leadership roles in tech companies like CSC, Patni Computers, and IBM for 15 years across India and US. She has done her MBA from IIM Indore. She has co-founded cross-border M&A practices in AXY KNO Capital Service Private Limited, which has presence in 50 countries. Currently building Inverse AI, a startup generative AI on mission to immortalize iconic leaders, more specifically with the goal of spreading Indian knowledge to the world with Bharat AI, Bharat LLM, and with offices in Nagpur and San Francisco Bay Area.
Recently, a research paper titled Infusing Artificial Intelligence in the Indian Knowledge System got the Best Research Paper Award in a prestigious event, Bharatiya Vigyan Sammelan in Gujarat, organized by Vibrant Gujarat, Government of Gujarat, and Vijayana Bharat. Recently, Inverse AI was the only Indian startup which was felicitated by Honorable Prime Minister alongside Google, Intel, and Microsoft. She is also a part of think tank of RSS and a vice president of Vishwa Mangalan Sabha.
With this, I invite our chief guest of today's program to kindly address the FTP. Ma'am, please.
For that lovely introduction. A very good morning to you all. Respected dignitaries of the dais, respected iconic educationists and visionary entrepreneur, Shri Sunilji Raisoni, next generation dynamic, incredible Shri Shreyas Raisoni in absentia, respected Dr. Vivek Kapoorji, Dr. Smita Nithi ma'am, Dr. Sakshi ma'am, and all here knowledge enthusiasts. I'm super thrilled to be here with you all. Super thrilled for a couple of reasons. A, generative AI is piping hot, and B, I'm in the company of folks who are eager to learn or on a journey to explore and learn a cutting edge technology which is changing the way we live. AI is going to touch everyone's life in the world. It is impacting every sector from agriculture to education to aerospace, to just name it. Artificial intelligence has been existing for many years, since 1956. But in the last 2.5 years, with the development of large language models like ChatGPT and OpenAI, made AI accessible to common man. Every morning you wake up with to find a new AI tool or technology in your box. Not a single day passes without something new happening in this field. This is democratizing AI like never before. The impact of generative AI on human is going to be profound. Just to understand the fathom and the gravity of this change, we can take the examples of discovery of fire by Homo sapiens 1.5 million years ago in the dark continents of Africa, or as profound as the discovery of electric energy, or as profound as the invention of World Wide Web in 90s by the British scientist Sir Tim Berners-Lee. But yes, one big difference in generative AI era, time is flying at the speed of photon. New technologies, new tools, and the models are coming to the marketplace on the fly. As per McKinsey's recent report, it is estimated that generative AI could add 4 trillion in value globally across 60 plus use cases. Just to understand what does $4 trillion means. The GDP of UK is $3 trillion. So generative AI is $4 trillion, which is adding new wealth globally. So I must say that the theme of the program, which is generative AI and its application, is truly remarkable. And to just share what kind of application we are using at Inverse AI. So we are a startup from heart of India, Nagpur and Silicon Valley, which is working on 3 applications. The first is immortalizing human. By using their digital avatars and preserving their legacy. We will have the facility, you can create your own avatar and you can be available for your children and grandchildren, even if you are not there. The second use case or the application we are having is imagining education, disrupting the way we learn by using or leveraging artificial intelligence. And the third one, the problem we are solving is the large language models, which are trained on Western data sets. They are concentrated on the global north. So if you ask, I want to explain and give the example. If you ask ChatGPT, who is the father of atomic theory, the answer or the response will come John Darwin. But then we all know that Maharshi Kanal, he came up with Anu, Renu, all those theories, but that mention is nowhere. So we as Indians, we have to bring that narrative for the world. So we are building on our own data sets and the new response which would be generated. So it will be started with the contribution of Maharshi Kanal. It will talk about Anu, Renu, and then it will talk about the contribution of John Dalton and J.J. Thomson and the Roosevelt. So it's the new narrative we are creating for the world, considering Indian knowledge system. So we all have the responsibility to make our nation a leader in AI revolution. I wish a huge success to this wonderful initiative and wish you all a happy learning time.
Thank you, ma'am.
As we come to the conclusion of our inaugural ceremony of FDP, let us now present token of appreciation to our esteemed dignitaries. May I now request our honorary chair, Dr. Vivek Kapoor sir, to kindly present a token of appreciation to our chief guest, Mrs. Preeti Ramakrishnan ma'am.
May I request Coordinator of FDP, Dr. Smita Neti ma'am, to present a token of appreciation to our honorary chair, Dr. Vivek Kapoor sir. Thank you, ma'am.
May I now request Dr. Vivek Kapoor sir to present a token of appreciation to our coordinator of the FDP, Dr. Smita Neti ma'am.
Request Dr. Vivek Kapoor sir to present a token of appreciation to our co-coordinator of the FDP, Dr. Sakshi Sadhwani ma'am. Thank you, sir.
With great pleasure, we invite our co-coordinator of FDP, Dr. Sakshi Sadhwani ma'am. She has more than 20 years of teaching experience and has published a number of research papers in national and international journals and conferences in the area of image processing, machine learning, and cybersecurity. She is IEEE Membership Development Head of GHRIT and has also worked as a Joint Secretary IEEE Nagpur Subsection in 2022 and 2023. She has received grants of 12 lakh under research project scheme from AICTE and winner of Global Teacher Awards in 2021.
Now, I request the co-coordinator of FDP, Dr. Sakshi Sadhwani ma'am, to propose the formal vote of thanks. Ma'am, please.
A very good morning, respected dignitaries on and off the dais, and dear faculty participants. I, Dr. Sakshi Salwani, co-coordinator of this FDP on Generative AI and Application, feel proud to present vote of thanks on this event. At the outset, on behalf of the organizing committee, I would like to thank the AICT Training and Learning Academy for funding our FDP and giving us the opportunity to host this FDP. I would like to express my gratitude to our chief guest, Mrs. Preeti Ramakrishnan, co-founder of Inverse AI, for accepting our invitation and gracing this event. Thank you, ma'am. I would like to thank our eminent speakers of this FDP, Dr. Nilesh Pikhale, IIIT Nagpur, Dr. Mr. Ashwin Balani, First Impression Technology, Mr. Somil Deshmukh, TCS Nagpur, and many more. They have accepted our invitation and they will guide you all, dear participants. I would like to express my deep sense of gratitude to our visionary management, Honorable Chairman Shri Sunilji Raisoni and Shri Shreyas Raisoni for his constant support and motivation for organizing such events. My sincere thanks to Dr. Vivek Kapoor, our Director GHRIT, for inspiring us and guiding us in hosting this activity. I would like to thank Dr. Smita Neti, our HOD and coordinator of this FDP, for sharing her responsibilities along with me. I would like to thank the whole team of FDP for their support, administrative staff, PRO departments, for helping us in hosting this event. My sincere thanks to all the participants. I hope through this FDP, you will enhance your knowledge and upgrade yourself. Thank you once again for all your support and all the best for the coming 5 days. Thank you.
Ladies and gentlemen, let's stand together in honor of our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे, जय 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 हे।
I now request all the dignitaries and committee members of FDP to kindly proceed to the atrium for group photograph. Thank you all for being a part of it with us.
Moving towards today's session, I would like to introduce our speaker, Dr. Nilesh Pikhale, sir. Dr. Nilesh Pikhale is highly respected expert in the field of generative AI and an esteemed faculty member at IIT Nagpur. He has extensive experience in the fundamentals of generative models and their application in education. His research focuses on the development of generative AI models that can create new data such as images, videos, and text based on pattern learned from existing data. He has published numerous research papers on generative AI and has been invited to speak at various conferences and workshops on the topic. Dr. Pikhale's expertise in generative AI and his passion for education makes him an excellent choice to introduce the audience to the exciting world of generative AI and its application in education. May I now request Dr. Pikhale sir start the session.
Thank you, ma'am. We are already running 45 minutes late, so I need to start at the earliest in order to cover all the topics that I have decided. Okay. So, what is the agenda for today's session? Is first of all, I was thinking to take a quick recap about the deep learning, how artificial neural network works, how convolutional neural network works. But I think I can skip that part and just consider that particular segment in the lab session. So with the practice and hands-on, I'll be able to clear those concepts quickly. The second topic that I'm going to cover is going to be introduction to generative AI, and followed by that a very interesting and important operation that is in generative models that is used, that is called as a con 2D transpose and upsampling 2D. That is the layers that are present in the generative models. Okay. Followed by that, I am trying to cover the part of autoencoders because once you understand how autoencoders are going to generate new images, then I'll try to slightly move towards the generative adversarial network. Right? I just want to give a disclaimer that autoencoders part will be again covered by the subsequent speakers, so I'm not going to put much emphasis on that autoencoders. But in order to explain generative models or generative adversarial networks, some portion of autoencoders would be very useful to understand how we are shifting from autoencoders to adversarial networks. Okay, so that is my agenda. And once we understand adversarial network, the next I'll be explaining in brief about deep convolutional generative adversarial network, conditional GANs and cycle GANs. Okay, so that is the agenda for these today's sessions from my side. Okay, so let's start with the first presentation, that is generative AI. Okay, so in this presentation, I'll be covering about how to define generative AI. Followed by that, I'll explain how generative AI model works compared to the classical machine learning or deep learning models. We try to distinguish between the existing classical deep learning or machine learning models, how they are different from generative models, that we get the clear idea about that. And then what are the different types of the generative AI models based on their input and output, right? So we can have different types of input. Input could be text, image, right, video, and same way the output can be anything like text, image, video, or anything. Okay. And finally, we will see what are the application domains where generative AI is extensively used. Okay, so that is going to be the first presentation. That is going to be thoroughly theoretical, and followed by that, whichever presentation I'm going to talk, I will be providing the supplementary assignment that is will support the knowledge that you are gaining in the theory will be immediately applicable in the some application. Okay, fine. So I know I'm going to ask very uh, simple question here. Perhaps you have seen this question many times. So if I ask you the simple question here, what is difference between AI, machine learning, and deep learning? Can anyone answer? Okay. By the way, I'm just assuming that you already are aware about the deep learning and fundamental working of the deep neural networks. Okay. So, can anyone tell what's the difference between AI, ML, deep learning, or at least you have studied earlier? Anyone? Yeah. Absolutely, deep learning. Because I. Okay, absolutely right. Right. So, machine learning. If you see this stack, AI is a broad picture, which is a superset. ML is a subset, and deep learning is again subset of ML. But if you want to distinguish basically what is machine learning is having some statistical, probabilistic, linear algebra, calculus based models which are going to perform some predictions. Right. So based on the history, we are going to perform some predictions. Based on the given data, we want to predict future. Right. How it is going to work. Right. So in this case, machine learning is based on the statistical, probabilistic, or this mathematical concept, and its job is to simply perform some predictions. Right. And the predictions are going to be in such a way that without explicit programming, that algorithm is going to learn the pattern that is present in our data. Right. Now you may ask, what's the difference between the machine learning and deep learning? So typically, if you see, these machine learning and deep learning concepts are not new, right? So in 1940 and 50, like these terms are first coined, right? But due to the unavailability of data, due to limited computing support, for 1950 till 2010, we were not able to adopt this technology. Because if you see, this technology is based on the input data. More the data you feed, richer will be the experience and more accurate will be your models. Right? But if I give you one simple statistics for today, at every second, we are as a human generating 7 MB of data for every individual or human population is existing now on Earth. Right? So you can imagine for every second, every person is going to generate 7 MB of data. Now you can do the calculation for every hour, every minute, every month, and every year. Right? So that huge corpus of data is getting generated. Right? So I'm saying this because nowadays data is there, we have computing resources, and that's why these fields are into existence. Okay. So if you want to distinguish now machine learning and deep learning is, machine learning models are simply mathematical models without explicitly programming. They are going to learn by themselves. But there is a limitation for ML models, that is, if the data size goes on increasing, the models may not be giving better performance linearly, right? So if you see, if the data size goes on increasing, at some point machine learning models are going to saturate their accuracy or performance, right? And that's why we are going to start with these deep learning models, in which if you go on increasing the size of data, automatically model try to learn those patterns from the huge data, and there it is going to learn the pattern in the data. It is going to make accurate predictions compared to the machine learning models. Okay, so that is the major difference, and the deep learning is based on analogy of how human brain works, right? So if I say you, let's say there is a car approaching towards you at very faster rate, what is your reaction to that? Let's say a car is approaching towards you at very high speed, what will be your reaction to that? You will run away from that car or you jump out away from the road, right? Because in our brain there are neurons which are going to create some memories, right? So we have different senses. We have visual senses. We capture information from our eyes. We capture information from our tongue, that is taste, right? We capture information by touch. We capture information by ears, right? So all these senses are capturing this information, and that information is being stored in your brain. That is comprised of billions of neurons, and they are connected to each other, right? So why you jump away from that particular car? Because you have memory about these kind of things. Maybe you have seen it in movies. Maybe some of you experienced that kind of accidents. You have seen different objects coming towards that faster rate, then you are going to be injured. So that sort of memory is present in your brain, and that's why you are running away from that particular car. Okay, and this information is processed inside your brain by different neurons. They have memory about all the things you are going to experience. And similar analogy we are trying to mimic in case of this deep neural networks, where we are going to create artificial neural network which is going to mimic the way human brain behaves. Right? For that artificial neural network also will be having some input, some processing and some output. Right? So input we are going to pass in terms of different data types like image, video, audio, whatever input you want to feed, and the network is going to process it, and finally it is going to give you decision. Okay, so same analogy we are adopting in case of deep learning, right? So this is how, in short, I can define what is machine learning and deep learning. And we know that in machine learning, we have two types of models, majorly, I'm saying supervised and unsupervised, right? So in case of supervised, you have input data and corresponding label will be there, and we are simply trying to find out relationship between the input data and corresponding label, right? For example, you want to train a model for, let's say, the tumor image is cancer or tumor parameters are cancerous or malignant or benign. In that case, we'll be having all the features related to cancerous and non-cancerous cells, and we have label that is cancer or non-cancerous. We are trying to find out relationship between these features and the labels. Okay, that is called as supervised learning, where we'll be having data as well as label. In case of unsupervised learning, we don't have labels, right? So we will be having simply the data in which model is trying to learn the pattern, and it is trying to collect the similar information together. It is forming the clusters, right? So that is called as unsupervised, right? But now, in case of machine learning, you might have seen the unsupervised learning, like clustering techniques are there, K-means and all those things. But there is another, you can say, category of models which are unsupervised. They are not trying to make the cluster, but rather they are trying to generate new information. Okay, so perhaps so far whatever models you have learned or whatever applications you have worked on, let's say object detection, it is going to tell you whether there is a particular object is present in the image or video or not. You might have worked on some algorithms where problem statement where you want to categorize the information, right? So just one example, I told you whether the tumor is cancerous or non-cancerous. Let's say you want to predict tomorrow's temperature based on the previous year, let's say day's information. So here you are performing the predictions, but there is a separate category of models which are not simply going to perform the predictions, but rather they are going to generate new information, right? And those type of models are referred as generative models. Okay. Now, if you see on right, sorry, on left, you can see here this is a typical workflow of the supervised learning. We pass the input data, right? We pass the input data, then we train a model. Model is going to perform some predictions. We'll compare with the predictions with the actual labels, and we'll find out the error, and then we back propagate the error to the model so that it is going to update its weights. Right. So this is how supervised learning happens. But in case of this unsupervised learning or generative models, here we have input data. We don't care about its label. Right. So it is not necessary. We must have labels for that. But let's say here we have input data X for which we don't have labels. Right. Now this model is going to generate some examples. Let me give you this generative models example in simple way, right? Let's say there is a let's take example of, let's say, ARM. Right? Perhaps he has composed more than 1,000 songs, right? Now here what I'm trying to do, I will feed, let's say, 1,000 songs composed by A.R. Rahman to this particular model, right? And this model is going to learn how A.R. Rahman composed his music, right? So different patterns, musical patterns, it is going to observe, and next time once you train this model by A.R. Rahman songs, then later on in future that model is going to generate new songs that would like just as composed by A.R. Rahman, right? So this is what the typical difference between your classical deep learning or machine learning models and generative models. Here we are not predicting whether the song is composed by A.R. Rahman or not. Rather, here the model itself is going to generate new songs that would be similar to just like A.R. Rahman would have composed. Right. You can take any example of, let's say, famous painter, right? So let's say X is a famous painter and who is having, let's say, hundreds or thousands of paintings. Now here the task is not to classify whether that picture or that particular painting is created by X painter or not, right? Rather, we want to train a model in such a way that it is going to generate paintings now new, just like that painter would have painted, right? So that is what the difference between typical generative models and the what we have other models like discriminative or the regression models. Okay, and these are the models that we are going to learn in today's theory and hands-on sections. Okay, so this is a clear idea or the difference between what is expected in classical machine learning models and the generative models. Okay, so I assume that you are already familiar with this neural network where we are going to pass the input, it is going to perform the feed forward network, then it is going to get the output, then loss calculation and back propagation to update the weights. Okay. Now here where the generative AI stands is again subset of deep learning. Right. So majorly in generative AI models, we are going to adopt the deep neural networks. Right. Maybe it is a recurrent neural network, convolutional or normal ANN, but majorly we are going to train the network or the model based on the neural network. Okay, so it is a subset of deep learning. Now, as I mentioned here, you can see the discriminative models are there. Here, we are trying to simply classify two types of models. Sorry, two types of input data. One is going to be, let's say, green, and other is going to be orange. Right. So, what classical model is trying to do? They are trying to find a decision boundary here. Right. So you can see this dotted line. The model is trying to find out decision boundary. That means it is going to classify two set of input data points. How the generative model is different, it is not going to classify, rather it is going to generate similar data points. Okay, so that is what the difference between generative and distributive models. Like for example, you experience on day-to-day basis, you are trying to search something on Google, right? So let's say you are typing your institute name, GS Raisoni, and immediately Google is going to give some suggestions, right? GH Raisoni, let's say placement record, GH Raisoni address, right? Who is, let's say, director of GH Raisoni. So similar questions you will get immediately. You are writing something and automatically it is completing your sentence, right? So that is what is happening. The input is your text you are providing, and it is generating new text that could be typed by you, right? Because you want to complete the sentence, right? So that is called as auto completion, where you are generating new text, right? You might have seen some applications, not the application, but the great example is ChatGPT, which is capable of not only the giving the summary of, let's say, some information, but rather it is also able to generate new codes. For example, in ChatGPT, if you ask, let's say, I want to write a program for quicksort, right? You just type there and it is going to generate the entire quicksort program, right? So for the students sitting here, they know how effectively you can use that ChatGPT tool, right? So here input is text and you are generating the code, right? And here you can see I'm not doing the simple classification or regression kind of thing. Rather, the model is capable of generating new information, right? Even now we have tools that can debug your code, right? Simply you pass your code and at the end it is going to debug and it is going to give you the corrected version of your code, right? So that sort of models I can consider it as a generative models, right? Even I'm not sure whether you have seen these kind of posts on LinkedIn or not. Simply you explain the, let's say, environment. For example, I'm saying that, let's say, cat is an astronaut. Contradictory statements are there. Cat is an astronaut. Animal, I'm talking about the being an astronaut. But the model is going to create a new image where cat is wearing that astronomical suit, and the image will be generated there, right? Even now we can simply provide the explanation about, let's say, some scene, right? And the AI tools are going to generate, let's say, a play based on that explanation. Right? It is going to create actors, it is going to create the script, it is going to create the vocal communications and all those things, right? So here we are not going to, let's say, simply classify regression now. Now the era is changed since 2018 onwards. I would firmly say that people have started adopting these generative models now. Right? If you go before 2018, we were doing simply classification, object detection, the YOLO models. Right? So all these models are to find out critical information from the existing things, and based on that we are supposed to take the decisions. But now scene is changed. We are supposed to now, AI models are supposed to now generate the new information. Okay, I'll give you simple example here. I'm not sure whether you guys use that technology or not, but at least faculties who are working in this AI or ML field, they should know that now you can see in Google Colab we have option generate using AI. Okay, so for example, now here if I open the Google Colab, earlier there was no option to create the code by AI, but now you can see there is an option start coding or generate with AI, right? So for example, you are working on the MNIST data set or you want to create simple CNN network. So here you just mention create. Okay, and simply you enter and it is going to create the entire network CNN, right? So you can see it is going to import TensorFlow, right? Model it is going to create, it is going to import the data set, it is going to create the model, whatever it is required, right? And finally it is going to test the accuracy, right? So as simple that you can see now, perhaps there are going to be some errors because it is generated by AI that you are supposed to debug, but hopefully there should not be errors as of now. Okay, you can see now here what I gave, what information I provided. I just want to create the convolutional neural network for classifying the fashion in this data set. With that minimal information, you can see now downloading is started and then even the training is started. Okay, if you go back 5 years where the generative AI option was not there, what you would have done? You have to first of all load the data. You need to understand the tensor flow. Then loading after the loading data, accordingly you have to define the model. You have to do the data pre-processing, and you can see how elegantly it is also pre-processing the data. Right? It is normalizing the data. Right? So now you can see here, without even making any much efforts, my accuracy in the first epoch itself is 80%, 190%. Right? So that sort of models I consider it as a generative models. Okay, fine. I hope this is enough to convince you that what is classical machine learning models, right? Where we are going to simply perform the classification of images, object recognition, etc. But now this is the era where you have to generate or create a model which are going to generate information, right? And the applications are very in the various domains. For example, if you see the entertainment industry, now people are working on the I would say already they have trained such models with the copyrights that now they can just pass the movie scene or even the entire movie, and automatically based on the scene it is going to generate the background score. You don't have to say that, okay, this is the horror scenario, right? Scary. This is the kind of romantic scenario. This is the action. Automatically, it is going to observe from the whatever the actions are being performed in your movie, and automatically it is going to generate the background score for that particular scene. Okay. And other example I told you, the music generation, right? So that is one of the examples. You can also generate images, right? So if you want to convert, let's say, uh, the image that you captured, let's say in summer, you want to convert that image, let's say in the winter, right? Then let's say there is snowfall. So automatically it is going to keep the background same, but it is going to rather change the environment by having some snowfall. Okay, so that sort of applications we can have in case of this generative AI. Okay, and now we can see just by writing one statement, I am able to create model even which is more accurate, almost 90% in the third epoch itself. Fine. So similarly, we will see these kind of examples when we move for the hands-on session. We will take leverage of this generate AI in the Colab, and immediately you will be able to complete your code. Right. So it is very easy now to write or train, or you can rather say design your models. Right. So you just need to think, okay, how this model should look like, and you just need to mention the information very precisely so that it is going to create the model that you require. Okay. So I have seen, I used to work, let's say 4 or 5 years back. I used to first attend the TensorFlow tutorials. I need to understand the syntactically what is every line, every parameter of that. Then I have to try and test for the small models. Then I have to test it for the bigger models little bit. Then feed the data, debug my code by myself, and so on. Right? It was very lengthy process. But now by simply writing one line of code, you are able to generate a new entire network with pre-processing us. Okay, so that is nothing but generative AI applications and all. Okay, so here you can see the discriminative technique where the discriminative model is going to take input as image of dog, and it is going to tell you whether there is a dog or not. But generative model is going to take input as a dog, right? It is going to understand what are the features are present in the dog. Tail is there, right? Ears, the shape of nose, the color pattern, right? So all these patterns it is going to learn first, right? And then based on that distribution of dog images, it is going to create a new image that is going to be a new dog. Okay. So let me give you one example again. Uh, human face generated by GAN. Okay, so you can see here, if I click this particular picture, right? So you can see here, all these faces are more realistic, right? Just like a normal human. Not sure how much it is visible, right? So all these faces are normal human, but these people don't even exist, right? These are generated by the model. These people don't even exist. These are created by the model, right? Now question is how to create such kind of models. First of all, we have to give all these passport size images, right? Cropped images to the model. What model is trying to understand? Okay, this is the pattern of the image where there are going to be eyes in this region, right? If the eyes are there, exactly below that there is going to be a nose. Exactly below there are going to be lips, right? So this pattern is going to understand, and next time it is going to generate a completely new face that even doesn't exist, right? So generative means we are generating the new information. Now the same analogy you can apply for different domain, different context, right? You pass music, it is going to generate a new music. If you pass the lyrics of different songs, it is going to give you new song lyrics, right? So this is how generative AI model works, right? Briefly, from bird's eye view, I am telling you this is how they are going to work. Okay, fine. So I think this much information is enough to start with the generative models. I'm quickly going to tell you what are going to be the applications of this model. For example, how to train these generative models. For example, ChatGPT, right? How it is being trained. First of all, we are going to provide a huge corpus of text to that ChatGPT, right? So maybe it is from the coding domain, maybe it is from different newspapers, maybe it is from different blogs, right? Whatever source available on the internet, right? So all this information we are going to feed to that particular network, that particular model. Now you can imagine, because if you ask anything to ChatGPT, it is going to respond optimally, right? Maybe you ask about the sport, maybe you ask about let's say your coding exercises. If you ask about let's say something related to physics, right? So all the information it is going to provide you optimally. So obviously for all domains it is supposed to be trained. So for all kind of information it is supposed to be trained on. Right. Now you can imagine how much data and how much time it will take to train such models. Right. So you simply see, you can relate with this example. So it takes almost 5 minutes of time just to train a simple neural network. That is on Google Colab. Very simple neural network, which is having only, let's say, three computing layers are there. With that minimal, let's say, parameters in the network, still it is taking 5 minutes. How many images are there? Barely I can say 60,000 or 70,000 images are there, right? But let's say you have trillions of images information, right? Huge corpus of text, right? And that you can imagine how much time it will take to train such models, right? So obviously, one thing is for training generative models, you must have a huge data. Second thing is you must have very huge computing power. Then only it is possible to train such models. Okay. So that is also true for the other deep learning models also, not only the generative models where the new network is going to be very deep. There also we have to train models on computationally intensive devices. Okay. Now, here we can say how we are going to train the generative language model. First of all, we are asking the model go read this pile of books, right? So maybe hundreds and thousands of books we are going to provide digital format to read that, and after that, once that learning is happening, we are going to ask what is cat, right? And it is going to answer cat is a domestic animal and all those things information it is going to provide. That is what happens with the chat GPT also. Now we are getting different variants of the chat GPT. Sometimes we are also getting code GPT, right? So now you don't even have to bother about the coding, because the generative models, they are going to you can say train on all the codings related information or text, right? So maybe there are some forums are there, from that you can read the information, right? So the popular forum is Stack Overflow, where you'll be having different coding related questions and people are answering that, and you also have flags, right, whether it is verified or not, right? So based on that information, people are training their models related to coding, and based on that trained model, now the model itself is able to generate new, you can say codes as explained by you. Okay, so this is related to the models which are based on the text. Okay, so if you see, I'm just giving you the type of input and output we can expect. So for example, if I'm having generative model which input is image, now output could be anything, text, image or video, right? So for example, if I'm asked providing the image to the model, right, that model is going to give the details about the what is their context in the image, right? For example, if I click the picture of this particular classroom and if I pass to this particular model, that model is going to tell that there are students sitting in the classroom and they are learning. Going to provide the count that these many students are learning. If you capture, let's say, image from that end, and if it is going to also capture this information, then it is going to tell you that there is a speaker who is speaking in this classroom and who is talking about the generative AI, and this it is going to tell you the details what is there in the particular slide. Okay, so that is image to text. We are passing image and we are expecting output as text, right? Then you already know chatbot is there, visual answering question is there, image search is there, right? Not sure whether you use those features or not on Amazon, right? So Amazon, we have option that simply click the any object you want to purchase and it is going to immediately show you all the recommendations. Even in Google Lens, if you click, let's say, picture of any object, immediately it is going to find out the corresponding URLs and it is going to tell you relevant URLs, maybe purchasing related or maybe the let's say you are clicking, let's say, image of Ford, it is going to tell you details about the folders. Okay, so that sort of applications where input is image and output is text. Then we have image super resolution. If you see the earlier a decade back, the quality of smartphones or maybe the camera quality was quite poor compared to today's. And let's say you want to convert those images into high definition images, then also this is called as image to image translation, right? Even I've seen some applications where old photos, 1960s, 70s, that 90s or 80s photos, they are going to take and they are going to convert into such a way that first of all color image they create, and they are also, we can also communicate to those avatars now, right? For example, a person is dead, right, and we have only the photo of that particular person. Now AI can create avatar of that particular person and we can directly communicate to that particular avatar. You feel like just a realistic person is for communicating to you. Okay, so that is input, we are passing image and we are creating the realistic or three-dimensional avatar of that particular person. Okay, that is image to image translation, right? Or image to video also we can see. Other case, we can now input text, right? And based on that input text, we want to produce the output is also text, right? Let's say language translation. We already familiar with this Google Translate, where we pass the input information of language and we want to convert them into desired language, right? So let me share one example that I survived in Vijayawada, right, in Andhra Pradesh. I survived for 2 years using the Google Translate, right? Because I was not able to communicate with local vendor. They don't understand Hindi also. I'm not comfortable with the Telugu language, right? They are not comfortable with Hindi language. How to communicate, right? So for our mate, we used to first of all mention what I want to say into Google. Google used to translate into corresponding Telugu language, and then used to play that particular sentence to that lady. Right. So that is language translation. Right. So input is one language. That is, you can also see that speech to text translation, text to language translation, and then from language to again audio translation. Right. So these all translations again come under the generative AI. Okay. Fine. And again, you can have these things for playing games also. You pass the information accordingly that particular what you can say actor in that game is going to play according to your information. Okay. Now, I think this is enough about the generic information about the generative AI. Right? I think you got the whole picture about generative AI. Right? I don't want to invest much time on the theoretical aspect. I just want to start as early as possible. The model creation, training, and convince you that how the generative AI works. Okay. Fine. I think I will stop here for this first presentation of mine. Okay. So if you have any questions related to this topic so far, feel free to ask. And because of time limitation, please limit your questions related to generative AI only. Okay. So that way we can make it most relevant. Yes, any questions so far related to generative AI?
So is there any common model that we could use for generative AI or something which is very common?
Common is not, because it depends first of all what is input and output. Based on that, I can recommend that okay, you can go. For example, you want to go for image to image translation, then autoencoders are there, unit is there, that is for right. For language to language translation, variational that transformers are there, right? So based on the context, you can have common models, right? But first of all, you have to define the context, what application domain you have to work on. Okay, once you finalize the input and output, then you will find out relevant models.
As you earlier told that all generative AI is to be unsupervised model.
Yes. No, not all. You will see there are some adversarial network I'm going to cover where label information is also important. But what the major difference between supervised and unsupervised is? In case of supervised, we are trying to find out relationship between feature and depth. Right. For example, let's show here function I was talking about. So in case of supervised learning, what happens? We have model F, input data is X and output will be Y. Right? Supervised means we are trying to find out relationship between X and Y. Okay, that is supervised. For example, we want to, let's say, predict the mortality based on the age. There is a relationship between death and the age of the person. As age goes on increasing, the probability of death goes on also increasing. So that is relevance is there. So that relation we are trying to find out in case of this supervised learning. But unsupervised learning, we are not first of all performing the predictions. We don't want to predict the sum what will happen. We don't want to classify the things. Rather, we want to generate new information. Now that to generate that new information, sometimes label information is also required, and sometimes it is not even required. But in case of unsupervised learning, we are not finding that relation. Only the distribution of the data we are trying to learn. Okay, and sometimes for that distribution, we need label. Okay.
So 98% of the cases we go for unsupervised model.
Mostly in case of generative, right?
So generative, we can tag it properly that generative AI means unsupervised only. No.
Yes. Yes. Right. So when we say supervised, there is relationship between feature and depth. Then if you are trying to find that, then it becomes supervised because we have data. Let's say cat or dog classification. We are passing images of cat and we are telling the model that you have to call this model as cat. That it is then model is trying to learn that okay, these are the feature of label cat. whiskers are there, right? Maybe the eyes of cats are like this, the face structure of the animal is like this. So it is trying to learn those parameters with respect to label cat. Same it happens with the dog. It is trying to learn the features of dog in that image with respect to the label dog. So there is relationship between image and corresponding label. Unlike if I say you now, just in the previous case in Google Colab, I type one text, create CNN model, right? So there I'm not trying to find out the relationship between the, let's say, input and output. There I'm simply asking some question to the model, and model is going to give me information. Like in supervised, we try to find out the label, right? In future, I'm passing the image of dog, and I want probability that this image has dog or not. Maybe the image is consisting of dog, it is going to give you probability that 98% the chances are that there is a dog in this particular picture. Okay, so it is in that sense it is different, unsupervised. Okay.
So text summarization comes under which category?
Please build up.
Text summarization comes under which category?
Text summarization input is text, output is also text, right? So text to text or sequence to sequence modeling is there, right? Now summarization means we have input, let's say a journal paper you are passing, right? There are tools that you pass the journal paper and it is going to give you summary of that paper. Let's say we are being lazy, we want to go through all the let's say 10 pages of the journal paper and simply we want to take the summary out of it. Right? One way what we can do, we can read abstract and conclusion manually and we can get the idea about the particular research paper. Now we are passing the research paper to this model which is going to read entire thing and based on that and previous experience on which it is trained, it is going to give you short summary of that. Right? So are we classifying the particular research paper into category? No. Are we predicting here something from that research paper? No. What we are doing, we are passing the input text and we are expecting summary of the text, right? So that there also it is generating some summary, right? So it comes under generative model, also it comes under the sequence to sequence models, right? So we are passing input sequence and we are expecting the output sequence. Okay. Yes, any other question? Yes, please.
Is it possible to use generative AI in text classification?
No, when you say classification itself is not generated, right? Because let's say you are saying the sentiment analysis, you are going to pass the text and you want to understand what are the sentiments in that text, right? So let's say somebody is abusing someone else on Facebook. We are taking that text and the text when you pass to the model, then the model is going to say the particular person who wrote this particular comment is angry based on the text that he or she used in the comment. So we are classifying. So some categories will be there. N categories. We are just taking the input text and we are mentioning what sentiment it has. So classification itself, what which comes under the supervisor, right? Yes.
So you said there are tools to summarize the content. If we are providing the content and it will summarize it. Can you give the example?
I never used, but yesterday I was exploring. Every link it is asking me some amount to pay. So that's why I have not explored that. But on LinkedIn,
it's part of LLP person, what Python is asking.
Okay.
That is part of LLP and they are.
No, NLP is obviously because NLP is the base which we are using for generation. Right. So obviously you have to do pre-processing in NLP. Then we are going to create generative models which are based on RNNs. Right. So internal working is going to be based on the recurrent neural network. Then the RNNs are going to generate new text information. Okay. So that is true. But even out of curiosity, I try to explore sometimes what are these tools are existing. But most of them are paid, right? But I have seen some LinkedIn posts. So these promoters are going to create video. They are simply typing your research paper and it's going to summarize it. So initially, maybe for free of cost, they are going to provide these kind of tools for you. But later on, you have to pay for it because nobody is going to make those kind of application for free of cost, but because you know how many challenges are there, how much amount you have to invest in order to design and develop these kind of models. Okay. Fine. Any other question before we move on to the actual model that I'm going to talk about, that is autoencoder? By the way, I see there are some students. Are you getting it, or it is completely out of syllabus for you?
So they learn deep learning.
Oh, that's great. Fine. Okay. So I'm deliberately skipping the fundamentals of deep learning because the title of the workshop itself is generative AI. So in case if you are not getting some concept, just make a note of these questions. Maybe offline or during lunch session, I'll be able to take those questions. Okay. Fine. So moving further, we will start actual first generative model, that is autoencoders. Okay. So as I mentioned, it is going to be unsupervised, where I'm not going to perform simply the classifications. Okay. So what it is going to do? It is going to take input as image and is also going to generate output as image. Right? So it is not going to classify in which category that particular image belongs to, or neither it is going to perform a regression model or prediction of something. Right? Remember, input is image and output is image. Okay. Before you move on this autoencoders, can I ask you a question? How the compression works? You have, let's say, a file of, let's say, 2 GB. You apply some compression algorithm and you may be able to compress it to 1 GB. When you decompress it, again you will get original file that is of 2 GB. Right? 2 GB, compress it 1 GB, again decompress it 2 GB. Right? So that is the whole principle of autoencoders. Okay, so keep this in mind. We are passing some input here, which is going to be mapped to the smaller vector space, and again we are reconstructing the same thing. Okay, now you may ask why we are doing. So I'll explain the full applications related to autoencoders. Okay, so this is the design of autoencoders, a model of the autoencoder. So let's say we are talking about the input as image, right? So what I'm going to pass here? Here I will pass input as image, right? Then we'll be having CNN network here, and this part is called as encoder, right? So before this latent space representation, this part is called as encoder. Okay. So what is job of encoder? It is going to take input image, apply different convolutional neural networks, right? So CNN will be there, max pool will be there. Then it is going to take that high resolution image, it is going to convert it to smaller feature maps. This smaller feature map, likewise, it is going to map into a single vector. Okay. Now this part on the left is called as encoder, or this part in the previous analogy we can say compression. Right? So image is going to have, let's say, a dimension of, let's say, 784 by 10. When we apply convolutional neural network, then it is going to compress it step by step, and it is going to make a small representation of that entire image into a vector. Right? Now, during the encoder part, all this information is captured and it is placed into the small vector. Now, the decoder part, what it is trying to do, it is going to take the small encoder part and again it is trying to reconstruct the same image. Right? So, here in the decoder part, we are going to apply the inverse of convolution, that is convolution transpose operation. Right? So, we'll compress it using CNN and max pool, and we are going to decompress it using reshaping, or maybe using the convolution transpose operation. Right? Now, here, whatever output image we are going to generate, that is going to be initially noisy image, because in the first iteration of your model training, it is not going to give you the correct output image that you should. Right? So here, what we are going to do, we are going to calculate loss. Okay, and how will you calculate loss? Just simply compare what is the input image and how it is different from output. If you see the difference, more is the loss. Right. So what you have to do? Pass the input image, make it in smaller vector representation, again reconstruct it. Now what model is trying to learn? First of all, how to compress the image and how to again make it high resolution. Right? So this is the overall behavior of the autoencoders. We are passing input to for the encoding purpose, and then we are generating the output from the input that is compressed. Okay. So now if you see the encoder part, this learns to compress the input. The bottleneck is nothing but where we are going to map the entire image into vector, and the decoder part is take that vector and again reconstruct the same image. Right. With example, what we can say here, I'm going to pass, let's say, image of cat, which is of 1024 by 1024 dimensions, and pass to the convolutional neural network. Then a feature map will be there, which is of one dimensional vector. Then again, I'm going to I think we need to make the host. I lost that privilege. सर आपका लेफ्ट हो मीटिंग लेफ्ट हो गया मीटिंग तो चालू हो गई
आता है आयुष
सर किया अभी
आपको पता भी है सब
I'm getting a single vector representation of that entire image. Now, in the decoder part, I'm going to trying to reconstruct the original output. Right. So when you first time pass this input image to the encoder, it is going to represent it to the latent vector space. Then from that, it is going to reconstruct. But obviously, in the first attempt itself, it is not going to generate the original image. First of all, it has to learn out of all this process of training. Right. What is the input and how output is supposed to look like. Now you tell me, how will you calculate the difference of loss here? In this case, what is going to be the loss? For those who at least know the deep learning fundamentals, can you tell me what should be the loss? Comparison. Right. Yes. So what is the specific name of that loss?
Loss function, sir. Create the loss function for that.
Which loss function? Yes, you are absolutely right there. Okay, let me give some cue for that. Something squared loss.
Yes, sir.
Mean squared loss. Right. So mean squared loss, if you take, what it is going to tell us? It is going to compare the pixel by pixel. So what is the input image, which is having, let's say, some dimension pixel? It is the corresponding pixel of input image and corresponding pixel of output image. Right. It is going to take the mean squared error of that. Right. And what will be the error if the input image and output image is exactly same?
Nearly equals to 0.
0. And that is what we want. Right. So if whatever image you pass to this particular network and the decoder is also giving the exactly same output image, that means this particular model learned how to compress and decompress. Right. And based on that, now we can have different applications. Right. And how this model is going to train? Initially, it is going to pass input, it is going to give some random output. The error will be huge in that case. Then that error will be back propagated in the network, and accordingly the weights of encoder and decoder are adjusted. Right. So we know that back propagation algorithm, so different optimizers are there, Adam optimizer is there, right? stochastic gradient is there. So different variants are there that you can use anything. But ultimately, which loss we are trying to minimize here, that is mean squared error. Okay, because you can see here we don't have some classification problem, rather the pixel we are predicting, right? And this is going to reconstruct the output. Now you may ask, what is purpose of that particular thing? We are simply compressing and decompressing it, but we can get different application out of it, and that is the basic principle of autoencoders, which can be used for different you can say applications such as image denoising. Okay, so for example, how this encoder network, autoencoder network, can be used for image denoising. Let's say you have some images, unfortunately that those are captured by a faulty camera, and you got all the images which are kind of blurred, which are kind of having some pepper salt noise, right? Some dots are there. You got these kind of images, and there is no way you can go back and again try to capture the similar image. Let's say it is very costly, right? So let's say you got some task, and let's say some remote area you have to capture some images, and you captured images, let's say by spending months of time over them. Now you come back and realize that okay, something went wrong and your images are quite blurry and some dots are there or some pepper salt noise. Now how will you recover that images? Right? So that is using this autoencoder. So how I can create this autoencoder now? I take input image, I deliberately add noise to that image, and that will be my input. Now this noisy image will be passed to the encoder, and decoder will try to reconstruct that image. Now can you tell me here, whatever output I am getting, with which input I am going to compare this output, whether the noisy image or the clean image? Clean image, right? Because decoder's job is to generate clean images, right? I will take input image, deliberately make noisy, pass it to the encoder, then decoder is going to create a clean image, right? Decoder is supposed to create a clean image, so that's why I'm calculating mean squared error loss with respect to the clean original image. Now, this particular model is trying to learn if you pass the noisy image, how to generate clean image. Right? So here also we are generating the clean image. Okay? So input is noisy here, output will be clean. Now same application we can, the same network we can use it for our other application, let's say image colorization. Right? So how we are going to train? Can you tell me, let's say input is black and grayscale image, output is supposed to be colored. Can you tell me at least what should be the input, or how will you prepare your input? How will you pass the input, and how will you calculate the loss? Yes. First, let me tell what is going to be the data set: color images or black and white. Okay, so you will be having data set with all the color images.
Converted into grayscale.
Exactly.
Given input to input.
Yes.
Then output expected is a color image which we will compare with the original.
Absolutely. Right. So now we want to create a model which is going to take input as grayscale and it is supposed to convert it to a color image. Right. So what we can do? Let's say we have some images from very old age and those are in black and white or grayscale in color. We want to give realistic effect in this generation, and we want to make it color image. Right. So what we can do? First of all, we don't have to take the old images. First of all, we'll take our own set of images which are already in color in nature. I convert these colored images into grayscale by applying some image processing tools. We can convert color to grayscale very easily, right? So there are some algorithms are there, classical algorithms which will convert the color images into grayscale. Now we have two set of same images. One is colored images and second is the grayscale images. Now we will pass these grayscale images to the encoder, which is going to make them into lattice space, and then the decoder is going to reconstruct. But while reconstructing, we are going to make three channels: R, G, and B. The reason is we want output to be a colored image. Now, whatever reconstructed image is there, that will be compared with original colored image, right? And this is how we are going to calculate the loss. Now, what model is trying to learn? Input we are getting is a grayscale image, and output a loss is calculated with the color. That means it is trying to generate the colored images. Okay, and that particular process is image colorization. Fine, that is the second application of autoencoder. Right? Are you getting how the autoencoders are going to work? So these are the typical examples. So you can see input is grayscale image and output it is able to generate the colored images. Okay. So other application is sometimes we try to download some images which are which you are interested in, but unfortunately the host website is not going to provide it for free of cost. It is going to add some watermarks, right? And now you want to remove this watermarks, and if you use any normal classical algorithm to remove those watermarks, then you are going to add some kind of noise into the image, right? Now you can see, you know the idea now, right? So can you tell me now how this watermark removal is going to work in case of autoencoders? From student side, anyone? Those who have attended DL course, anyone? Yes. Again, idea is going to do the same. Yeah, please.
Same logic is applied.
Yes.
If we want watermark removed image. So first we will take a watermark image, remove the watermark, and give the image to the encoder. And then the watermark, the embedded image will be given to encoder. And after decoding, we will get a clean image without watermark. This has to be compared with the original image. If it is same,
without watermark. Right. So as simple as that. So in this application, you can see the network is same. Only what is changing? Input and output. In case of image denoising, noisy image we are passing, we are expecting clean image. In case of image colorization, input is grayscale, output is colored. In case of this watermark, input is with watermarks, output is clean. Okay, so you can see same model can be used for different applications. Okay, so again, all the theoretical aspect is mentioned here, and we have one application for the. I think you are support. Please share this folder with the students and all the participants. I'm not sure whether I have shared it or not. Okay, I'll share this link with if you are not registered group. In WhatsApp group, everybody is there.
yes, it is a
But for students, I think there is no WhatsApp group.
right side.
Okay, I'll share this folder in WhatsApp group. You please share with the students. Okay, and change the access to that. than there. Okay, so how it is different? So you can see here, typical network is there, right? So where we are having input of 256 by 256, that image is becoming now 128 by 128, 64 by 64, 32 by 32, and 16 by 16. Right? So this is how convolutional and max pool layer is happening, and the image is that picture map is getting smaller and smaller. Right? So that is possible with the normal convolution operation and max pool. But if you see after this, it is reverse is happening. That is, you are getting 32 by 32 image or feature map. Then you are converting into 64 by 64, 128 by 128, and finally 256 by 256. Right. So in short, in encoder part, I am trying to perform the operation of convolution, and in decoder, I am trying to perform transpose convolution, or it is called as an upsampling. Okay, so there are two choices in this deep learning frameworks, TensorFlow or PyTorch. You can either go for upsampling or con 2D transpose. So these are the two options are there in TensorFlow. Okay, now there is a difference between these two operations. I'm deliberately taking emphasizing on only that part because traditional or classical convolutional neural network is very easy to understand and is very easy to find out number of features in every layer. But it is slightly different in case of reverse process, so where we have to perform upsampling or on-2D. Okay, so you can see here now in case of convolution, what happens? Input image is there. After max pool, the image size will be reduced. But what we want in decoder, input image is there. Now we want to increase the size of the feature. Right? How to do that? One option is using upsampling 2D. Right? So upsampling is 2D is nothing but simply we have to replicate the pixel values. Okay, so how it is happening? Let's say input pixel is this red color. So if I apply 2 by 2 upsampling, then every pixel is represented as 2 by 2 grids. Okay, so you can see there is a red pixel, we get 2 by 2 grid for red pixel. There is a purple one, so likewise for every pixel we get 2 by 2 grid. If it is 3 by 3 upsampling, then accordingly 3 by 3, 3 by 3 we get. Okay, but this is not advised, at least in generative models, because it is going to create the artifact mode effect. Right, so some kind of clustering of pixels which is going to create in the output image. Okay, so that's why it is not advised. Typically, what advice is to go with the transpose kernel. Okay, so on 2D transpose itself is taking saying that first of all we are making reverse of convolution, and second thing is we'll be having convolution mask also in this layer. Unlike in case of upsampling, we don't have any parameters to learn. Simply what we are doing, we are replicating the number of pixels. So we don't have any feature to learn or any kernel associated with that upsampling, right? Where we have to find out the optimal values of weights and bias. Right? Simply here we are trying to convert the input image to upsampling. Unlike here in on 2D transpose, we have to take input image and we have to apply mask, and based on that mask, the size of the output will be increased. Okay. For those who are not able to recap properly what is the convolution, so you can see here the simple convolutional operation. What happens? How convolution happens? I take this particular mask. Right, so let's say this is the input image, this is the mask, this is the reverse operation. Okay, so this is the convolution. Okay, so 4 by 4 input image is there and 3 by 3 kernel is there. So how convolution happens? I take that mask, I'll apply corresponding location in the image, I take weighted sum and update in the output. Okay, so this mask will be placed first of all this first 3 by 3 elements. It will perform the corresponding element multiplication. Sum will be stored here. Then we are going to shift it by one place, right? And then again we are going to calculate the remaining values. Can you anyone tell me why the input size is 4 by 4 and output size is 2 by 2 here?
Yes, striding by
Starting by 1, right? So we are performing slide by 1. That's why we are getting output sizes 4. What if I slide by 2? Output would be we have to perform padding, right? So that it will take care of the remaining or the pixels which are not present in the image. We have to take care of the elements by the corresponding kernel multiplications. Okay. So this is what happens in case of convolution, right? But in case of transpose convolution, what is happening? First of all, we have to get the input which is of smaller in size. We are applying 3 by 3 kernel, and which is giving me output which is of 4 by 4. Right, so it is quite in the reverse direction.
So
Normal.
Can you explain how it is like we understand it?
That's temporal. Right. So first try to understand one encoder is doing normal convolution operation, which is trying to reduce the size of feature, and other is trying to increase the size of feature. Okay, and how it is doing? So input is given, and we are going to apply 3 by 3 kernel. Right. So it is explained here. Right. So input size is here 2 by 2. Kernel size is 3 by 3. Right. What we do? We will take this element, one element, 55. We'll multiply that 55 with all values of that mask. Okay, get the broad picture. What is happening in convolution? We are applying mask and we are reducing it. Now what we want? We want to apply mask in such a way that it is supposed to increase. Right? So what is happening here? You follow the direction from right to left in this image. Right? So we are starting it here. Input size is 2 by 2. So by mistake I mentioned here 3 by 3. The kernel size is 3 by 3 and input size is 2 by 2. Okay. So input size is 2 by 2 and we are applying the mask which is of size 3 by 2. So what is the process? I take 1 by 1 pixel from the input image. I'll multiply that pixel value to all the elements of the mask, and then I'll be generating one 3 by 3 feature map. Right? So how many mappings would be there? I'm taking every pixel from the image and multiplying every value of the mask. That is going to create one 3 by 3 map. So how many such maps are there? Will be there 4, right? Because how many pixels we have in this image? 4, right? So 4 such for this 55 pixel will get this particular matrix. For next 52, I'll get another matrix. For next 57 pixel, I'll get this matrix, and for 50, I'll get this matrix. Right? Try to understand, because that is the most important thing in case of generative models, right? Because typically we follow the convolution operation, it is very easy to understand, but slightly it is tricky in order to understand the reverse process. Right? Once you understand this, you will be able to design the autoencoder components based on the parameters, features, and everything by calculation. Okay. Now you can see here, I get 4 such matrices, right? And how many elements are having in case of this particular input matrix? 4 pixels, right? So accordingly, I will add all these 4 matrices that 3 by 3 are generated. It is going to create a 4 by 4. Okay, so you can see here in this example, I got here a smaller example here. So 55 will be multiplied to this small kernel, and I get 55, 162, 167, 320 t. Right. So sorry, it is going to add later on. So if I multiply this input image with this mask, I get particular values, right? So that I'll place here in this 3 by 3 matrix. Then 52 will be multiplied to these all elements. Then I will place in this region in the same image, right? Then 57 will be multiplied, so it will be somewhere here, and 50 will be multiplied, so it will be somewhere here. Okay. So let me try to annotate so that it will be easy for you. Okay. So this 52 will be placed here. So 55, 52 will be placed here. So for 52 it would be
Sir, in the next row it is not here.
so next row is with the different strides. So follow me with this for 57 I will be getting some 2 by 2 matrix overlapping here, and 50 it will be somewhere here. Okay, so you multiply this particular kernel by 55 and you will get this first location of 2 by 2. Right, save it, then multiply 52 by this particular kernel and you save in the next 2 by 2 location. So previously whatever updated by this 55 will be placed here, and on top of it I am adding the summations or multiplications are created by this 52. Right. So here you can see you are getting here 162. So this is
Value will be replaced.
not replaced, added. Right. So you can see here in the middle you are getting 162. Why? Because here I am multiplying 55 by 2 and that will be placed here. So 55 by 2 will be 110. Right. Next time I'll be adding here 52 multiplied by 1 at the same location. So it is going to be 160. Right. 52 will be multiplied here, it gives you 104, that will be stored. Right. And you can see at the middle here, we are adding those values how many times? Can you tell me how many times we are adding at this location? 4 times. Right. So contribution from this 55 multiplied by this color, or all the 4 elements will be multiplied, and center location, the contribution of 4 is happening. Now you can observe here it is happening in the reverse direction. In convolution, what happens? We will take nearby pixels, will apply mask and will try to store at the one location. But now what is happening? We are taking one pixel and we are storing at multiple locations. That is quite happening in the reverse order. Okay, so that is the only and the most important aspect of these decoders. And many times I have observed, even the first time I was reading these particular resources, I struggled a lot to understand what is happening in the output layer. Because though we are saying it is inverse of convolution, because while designing the models, you must pass the parameters appropriately. And you'll be able to pass those parameters once you understand this 2D transpose process. Okay, and that's why I deliberately created a separate presentation of 2D convolution transform. Okay, fine. So now it's almost 140. Okay, so there are still 3 minutes are there. So if you have any questions so far related to this, let me know.
So what would be more applications of encoder? It's one very perfect file in images. What are the more applications for encoder?
Auto encoders. Yes. Auto encoders are typically designed for images. Right. So if you want to, let's say, work on translations, right? So then you have to use RNNs. But when you work on text data, then the network is going to be different. That is RNN, and the analogy is going to be slightly different. Yes. Any doubts so far?
So this cannot be applied to music.
Music itself is run sequence again, because music beats are there, some time information is there, right? So that music we have to first of all convert it to sequential information. In the video also, if you break down, it becomes image, right? Frame becomes again in sequence. So that is combination of CNN and RNN, because frame wise you are passing one image and you are having containers.
Encoder is typically for static effect.
This example is for static, but you can convert and tune according to the RNN. Because in RNN, what is there? If you pass the input text, then neural network is going to be ANN in between that. But if you have sequence information which is in terms of image, then RNA inbuilt is which is having CNN, right? So that be passing. Only thing is you will be having now recurrent connections. Okay, so RNA is a term which is going to take care of the sequence information, but sequence information can be imaged as you said in the video, because sequence of images you are passing. If the sequential information is important in case of your application, then it makes sense. For example, let's say you have a short video of 5 seconds, somebody is running in that from left to right. Right. So that sequence information you have, the object is moving from left to right in that particular sequential time axis. So that sequence information is important. You want to say that after some time step where that particular object the video is going to be there.
Mathematical logic which we have explained right now will be same, but it will be applied as per the RNN model.
Yes.
But this mathematical multiplication and the reverse process.
So this is for only CNN. The mask and everything is relevant to image.
But increasing the matrix size, that logic will be same, no?
If you are working on image and video, it doesn't capture the same. But text information, there will be different process. Yes.
Lunch, sir.
I'm sorry, I was supposed to conclude here the generative adversarial network, but unfortunately we lost 45 minutes and we were able to complete only the autoencoder part, right? So in the next session, that is going to be theory plus hands-on session. So better you come up with your laptop so that the whatever resources I'm going to share with you, so immediately you can train those models for autoencoders and so on for a generative adversarial network, and you can appreciate the process of theory and immediate applications. Okay. Okay, any other questions?
Thank you so much, sir, for this informative session. So may I request to all the faculty participants proceed for the lunch, and our next session will get start at 3 p.m. time. Lunch
For you, this college
For the faculties, see, I have shared one link in WhatsApp channel. You have to open that link. All of you, just click confirmation. Are you able to see that link in the WhatsApp group? There is a link provided to you. You have to click on that, and you can see here on top right corner it is going to ask you registration and login. You need to complete the registration process. Yeah. Then. No, but sir, on top right corner there is a registration option is there. Event code is coming. No, on top right corner you check. Registration is there. Yes. You just need to click on registration and fill the information to get registered. Inside your email ID, with registered for that. Okay. You can share that link in Google Drive for that. You have access on your laptop, right? So I'll update there so that you don't have to start WhatsApp channel again.
इसका रेडियस क्या है? ये वाला ऑन है और ये शेयर करिए ये पूरा नहीं उन्होंने डाला चले गए थे ये जो लड़के उन्होंने डाला
Okay, in that drive folder, in the links file, there is a link file. Text file is there. You have to open that, which this link that I'm asking to open, that is there. Okay, so you can see here first course link is there, then the event code is there. So once you click on first that course link, then it is going to show you on top right corner on that link, register or login. So you have to click on register, complete the registration process. It is copy pasted in the same file or in your WhatsApp group. It is there. Okay, you can see here. In the links, we have event code also here. Right? Make sure while copying, you are going to copy exactly. Even if you add one more extra space, it is going to throw error. But before that, first you have to complete the registration process. Then you can use that event code. How many of you completed the registration process?
Registration is done.
Registration is over.
Event code I entered.
And not what is the problem that others face?
I think internet is slow.
You should enter the relevant information. It is compulsory that you enter. Remaining, you may skip. Is it mandatory? Then see. You select whatever.
Roll down. I think you should next that whether we have period.
Regulation go back. So, this thing user is already used by something. Next, code is in the link. Okay. What is already used? Now we are able to compare first. Click on start first. Click on start button. Check the mobile. Click on notification. How you do
उधर जाओगे मैडम?
Okay, so how many of you successfully registered and enrolled? Okay, so what we do for next 15 minutes, I'll quickly tell you how ANN works and how CNN works. Okay, because it is observed that some of you are still struggling with the forward backward propagation, so I'll quickly explain for 15 to 20 minutes. Then we will start with the autoencoder hands-on, and followed by that we will start with the generative address training. Okay, that is what I'm planning now. So meanwhile, this session is being launched. Okay, those who have opened this course, click on start button. Let me start launching the cloud instance. Let me help you out. lost 15 minutes in the process. Okay. So in this particular course, first two chapters we are going to see how to create a neural network and how to create a convolutional neural network. Right? So here, just for a few minutes, pay attention here. Later again, I will help you to log in. Just pay attention for a few minutes here. Then we'll proceed. Okay, so this is the simplest application where we are going to classify handwritten image digits classification. If you recall from first session, what I did, I simply wrote one statement that I want to create a convolutional neural network which is going to classify the feminist data set, right? So the entire program was generated by AI and simply you were clicked on the run cell button. But now here I mentioned the step by step what we are doing here. So you can click on the first chapter here, double click on the first chapter, so it will open 01 underscore list, right? And this is the kind of data set we have, image data set, and our job is to classify these images into their respective digit categories. Okay, so what we have to do? We have to create a neural network which is going to classify these images into the digit category. So, for example, if I get this image, it is supposed to classify it as a 0. If I take, let's say, this image, it is going to classify it as 8. So, the thing is that whatever handwritten digits are there, we have to classify them into correct digit category. And for that, we are going to create a neural network, right? So all the explanation is provided here. So I'll not go into the very fundamental what the training said, what is pre-processing, etc. I'll directly tell you where you can create a model. Okay.
Sir, how to access this file?
So click on this findable key.
How to get this?
You click on launch button, right? Yes. Then it is going to pop up the new. Right. Okay, so you can see here from TensorFlow, we are importing sequential class and we are going to create an instance of that, and that we are going to call it as a model. Right, so we have to create a neural network. So we are going to import sequential class and we are going to create instance of it, and in that instance we are going to add layers. Right, so as I mentioned, our brain is comprised of neural networks which is going to have input like we are getting senses from different senses here. I'm watching here, so that information is captured and is stored into the brain. Okay, same way, artificial neural network I'm going to create which is going to have some input, then processing, and the output system will be there. Okay, so in this case, what I'm going to do is I'm going to create a dense layer which is going to have some neurons. Okay, just like in human brain we have neurons, here also we are going to create some neurons here. And in the first layer, I'm going to have 512 neurons, and activation is going to be ReLU. Okay, can anyone tell me what is ReLU activation? Those who are familiar with deep learning. Right. So what is its purpose? To add. Yeah, just we want to introduce that to add the non-linearity in our decisions. Right. So that means if our data set is non-linearly separable, so in that case we have to use that value activation function. Okay. You can see here I am mentioning 784 as the input size. That means we are passing input image is of 784 dimension. Okay. Normally our input image is of here in MNIST data set it is of 28 cross 28. Okay. But I'm creating artificial neural network, so it is not going to accept the entire image in two-dimensional format. So I have to flatten it. So image I'm going to convert into one-dimensional format. Okay. So 28 cross 28 image will be converted to a single 1D array of size 784. Right. So for 784 dimension, that is going to be the input here. Right. Then I'm going to create one more hidden layer. right? For adding further more complexity in the network. And finally, I am creating the output layer, which is going to have only 10 units. Right? Why 10 units at the output layer? Why only 10 units? This is digit classification, right? So digits are in the range 0 to 9. So 10 classes are there. So output layer you will have 10 units. Okay. And finally, here we are going to create model summary. So it is going to say that okay, first layer is having 512 units, hidden layer is there, and output layer is there. Okay. And then we are going to add loss, just like in morning we were talking about the mean squared error. Here, this is classification problem, so we are going to use the categorical cross entropy, right? And finally, you have to fit the model, and it is going to train accordingly. Okay, so here simply we created an artificial neural network which is going to perform the classification of images from 0 to 9. Okay. In theory class session, what we discussed about the convolutional neural network. Okay. So in this neural network, what we passed, image is flattened into one-dimensional array that we are going to pass here. But in case of this network, it is not going to consider the nearby information, right? Because let's say we are talking about the picture of a cat. So some set of pixels nearby is going to comprise the eye of that particular cat. Some pixels nearby are going to comprise the nose of that cat. So that neighborhood information is not considered in artificial neural network. So that's why we are going to switch to the convolutional neural network. Okay. So as of now, don't go step by step and try to understand. Just simply click here, kernel, and run all cells. Right. So if you click on run all cells, finally you will see that model is getting trained here, and now model's accuracy is 97%. Right. So this means that you created a model which is 97% accurate on classifying these images. Okay. So I'm just trying to give you the flavor that how to create a artificial neural network. Okay. Then you can create click on the third chapter here where convolutional neural network is there, right? So in this case also just simply go and run all the cells. Okay, you can see this is how normal typical convolutional neural network is there. So we have input, then we have a convolutional layer which is going to reduce the size if required if padding is not supported. Then I'm having max pooling which is going to half the size, right? If I use 2 by 2 max pool here, then convolution dropout max pool. This is the series of layers we are going to apply, right? And finally, once we train this model, you will get first just shut down. Okay, so you can see here how I'm going to create that convolutional neural network to just focus on this cell. Here, I'm going to, you can see add convolutional 2D layer where 75 kernels I'm using, and each of size 3 by 3 is style equal to 1 and activation function as value. You can see here input shape I'm passing as 28 cross 28 cross 1. Meaning is that input image is of dimension 28 by 28, and there is going to be only one channel because this is the grayscale image. On left panel you can see chapter number 3. Okay, so you can see here. You can see here I'm adding the 2D convolutional layer, then batch normalization in order to normalize the data, then convolution 2D, then max pool, convolution, max pool, in this fashion and creating the layers. And you can see if you print the model summary, you will get to see that the dimension of that image is going to be reduced in every layer. So you can see we started with 28 cross 28, then it becomes 14 cross 14, then it's 7 cross 7, then 4 cross 4. Right? This was happening in case of your encoder part of the autoencoder. Right? In every layer, we try to reduce the size of your feature map. Then we are going to restructure the decoder. Okay? All of you know this convolutional part, convolution layers, how we are going to reduce the size of your feature maps in every layer. Okay, so you can see finally in this case the accuracy when I use convolutional neural network is 94%. Right? Okay, so let me guide you for a couple of more minutes. If you stuck at any point. Just want to know my minutes. So we have used convolution. Okay. And now we are ready to reach. We have started. We are programming the layers. How many layers we have to use for this complete empirical studies? You cannot prove that only these many layers are supposed to be there. First of all, because if you are solving this index problem and the output, the complexity, we have to compromise between that get the output or the complexity of the layers. That's why we have decided as a 3, 4, 5. No, complexity is not the point. Ultimately, what I want some model which is more accurate. For that, you say it takes 1 hour extra also, then it's also fine. But ultimately, what I want is a model which is going to perform the predictions which are more accurate. I don't want to use that accuracy. Right? Because just because it is one time. Once you train model, that is fine. That train model can be used at any number of times. Right? So, it's 28 images. That is a two-dimensional image. Yes. You have told that you have converted into single image 728. 784 dimensions. 784. So, why we use some? For ANN, the input is expected in terms of 1D form, right? Normally. And for convolutional neural network, we are using the mask colors, right? Which is expecting input in 2D form. So, how many colors you have used for 784? It is not necessary that there has to be a fixed number, right? You can use 100, 200, 500. It depends on the problem statement you are solving, your application. For example, in this case, the problem statement is quite simple. Only 10 classes are there and students. Yes. Yeah, and it is not realistic like we are classifying thousands of images or thousands of classes. Simple 10 digits are there, so 10 classes are there. For this, even we create 3 layers, input, out, hidden, and output. That is going to be sufficient. If you add more complexity, it is also fine, but it could cause a problem of overfitting. Overfit means simply what is happening. You have told that adding also. Padding is not related to layers. Padding is with respect to that image. Right. For example, when you apply the mask, you are going to reduce some size, and sometimes your mask is going to go outside the image. Because when you apply the mask, it goes outside. And how will you multiply the outside if there is nothing? So for padding this, you are just adding zeros in that zero boundaries. And then zero. It is recommended to add zeros. Right. If you add one, then you go to add that information. Okay. Okay. So, actually, if I would like to differentiate between neural network and convolutional neural network, what I will do is that if my image is one dimension or if my image is two dimension. So, if I have a one dimension Yes. That is one major difference, and the difference is very obvious because in two dimension we preserve the locality. One dimension that locality is not be preserved. Right? That's the reason one other thing. Okay. Okay. I think this is enough for this CNN and how we have just learned this part.
सर्व इतक्या बाहेर गेले
किसी को भी लिंक नहीं देना, अटल वाले लिंक नहीं देना किसी को।
यूट्यूब वाली लिंक नित्य मैडम ने इस पे डाल दी।
कौन से पे? कब डाली?
सुबह यूट्यूब की लाइव लिंक
नहीं देना है किसी को भी।
हम डायरेक्टली देखेंगे।
ऑफलाइन को नहीं
कौन मेरे को बात नहीं।
Okay, so students who are carrying mobile phone, they can also register now. Right, later on at home you can go and access to the course from your lab. Right, so you just register. Okay, so without any further delay now, so let's start with the autoencoder part. Okay, so that drive folder. Now just keep this particular NVIDIA instance as it is. Don't worry about that. Just keep it as it is. I will focus on this encoder part. So before that, on that drive folder, there is a chapter number 4 upsampling. Okay. So in that upsampling, there is a Jupyter notebook. You have to open it with Google Colab. Okay, so you see here there is a folder with the chapter 4 upsampling and convolution 2D transpose. You have to open this. I would recommend you to use your personal mail ID to open, because if you are using institute mail ID, perhaps Google Colab is not available for your institute mail ID. Right, so that personal mail ID you are supposed to use. Okay, so if you open this on Google Colab, right, it is going to look like this. So those who are not familiar with the Google Colab, it is again the free cloud instance and resources are provided for practicing purpose ML and DL domain, right? So you open in Google Colab this file from chapter number 4, upsampling and convolution 2D transpose. Okay, so this will clear your doubt about how upsampling and convolution 2D transpose works, right? So to understand that, first of all, you need to understand the convolution operations, how it works. Then we will be able to understand this upsampling. Okay, so if you recall in upsampling, what I told you, if this is the input of image of 3x3, if I upsample it by 2x2 upsampling 2D, then the image is going to look like this. Okay, so same thing we'll try to understand using the code here. So I'm taking the input as array of size 3 x 3, right? So the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the matrix of size 3 cross 3. We will apply here upsampling 2D and we'll try to understand how it is going to look like as output. Okay. So for that reason, I'm going to reshape here X because we want to pass it to the model. So it is expecting output in the format like this. So one, that is only one image I am trying to pass, or one array I am going to pass. Its dimension, so it is going to be 3 cross 3 and it is having only one channel. Right, we don't have color information and all those things, so that's why we are mentioning it as a only one, right? Then, and what I'm doing here, I'm creating a model and I'm passing this input to that particular model, and here you can see I'm applying upsampling 2D with the size 2 cross 2. Okay, and what we are expecting the output dimension here. Okay, so it is giving me output dimension 6 by 6, right? Because input is 3 by 3 and we are applying 2 by 2 mass, so that information will be copied twice, right? And if you pass that x value to the model, so it is going to look like this, right? Just like that same information copied multiple times in 2 by 2 cell. So 1 is copied in 2 by 2 cell, 2 is copied, 3 is copied, and likewise every input pixel is copied 4 times, right? And that's why now input shape is increased from 3 by 3 to 6 by 6. Okay, and that is one way to increase the shape in case of decoder network. Right, in encoder it is quite easy to reduce the feature size, but in case of decoder we have to go on increasing every layer. Okay, now this is one way, but this is not advised in case of generative models. Right, sometimes it is going to result into artifact effect. That means some pixels are saturated in region. Okay, so that's why they recommended that use count 2D transpose operation. Right, so it is reverse of convolution and also it is having features. So if you see here, if I see the model summary, there are no trainable parameters. What is the reason why there are no trainable parameters here? In convolution, what is the trainable parameter? The mask variable, right? Or the mask weights that we try to find. That we call it as the trainable parameters. But in case of this particular upsampling 2D, there are no trainable parameters. Why so? Mask is not at all required here because we are simply copy pasting that multiple times, right? So there is no concept of mask in upsampling, right? Simple given image, we are copying pixels and we are making it bigger. There is no concept of learning parameters in this operation. Unlike in case of this quant 2D operation, transpose operation, we have learnable parameters because we will be having mask application as well also. Okay. So again, I follow the same thing here. I take the input here 3 by 3, right? And I will create a model, but rather using here upsampling 2D, I will use quant 2D transpose. Okay, and you see there are multiple such parameters are there for quant 2D transpose, like this mask size, stride size is there, kernel initialization, right? So kernel initializer means first time when you are going to create these masks, what should be the weight of those masks, right? Because there are different ways we can initialize the weights, right? Denormalization is there. We can initialize randomly also. We can initialize it to 0 also. But for the simplicity to understand this concept, we are going to initialize all those weights with the ones. Okay, and you can see now model is having configuration and it is going to output as 4 cross 4, right? And we have now learnable parameters, that is 5. Now here I am having mask that is only 1 and its size is 2 cross 2, but learnable parameters are 5. Can anyone tell me why learnable parameters are 5 here even though mask size is 2 cross 2? No, mass size is given 2 cross 2. So total number of weights would be 4. But why we are having one extra weight here? If you see with have concept of weights and bias, right? So if I talk about the normal equation of line, y equal to mx plus c, there is going to be slope and intercept. Based on these two values, you will be able to draw the line, right? So that c is nothing but the intercept value. Okay, same concept is here also. For every mass that we are going to apply, corresponding bias value will be also there, right? So if you have any, let's say 2 mass, if I change here, rather than having 1 mass, if I make it 2 mass, now your weights are going to be 10, because we'll be having 4 weights per mass, that is total number of 8 weights plus bias value for every mass, right? So 2 masses are there, so every mass is having 2 bias values, so total learnable parameters are going to be 10 here. Okay, so this particular on 2D transpose operator for the layer is advised in order to create the upsampling or that decoder layer in autoencoders. Okay, now if you see here, I have created one file for you. Let me open that. Autoencoder file is there. So do one thing, simply run all the cells. Okay, so here what we are going to do, we are going to take fashion in this data, right? So in the fashion in this data, what is there? These are the images are there, right? So older image, we are having some images of shoes, right? T-shirt is there, jeans, trouser, jackets, so all this sandal is there. So all these fashion images are there. What we are going to do, first of all, we are going to take those images, we are going to compress it and reconstruct it, right? So that is what we want to do, right? So you can see here basic encoder which is taking input as this shoe, which is quite clear compared to the what is reconstructed, right? So what type of this, whether it is lossy or lossless, reconstructor? Lossy, because while reconstructing we are losing some information here. Okay, and because this is the simplest kind of a hello world program, this deep learning, this data set, so we don't have enough data set also. The picture quality of the input images itself is not much clear. Okay, and that's why we can see here output is generated in this fashion, but still it is quite matching to the original input image. So that means we have to create autoencoder which gets this sort of image and it is going to reconstruct this. Of course, the first version of autoencoder is useless because we are simply demonstrating how autoencoder works by passing input to the encoder and reconstruct it using decoder. Okay. So for that, if you see here, I have created a class autoencoder which is going to create here. It is having two part components. One is encoder and other is decoder, right? And you can see in encoder, first of all, I am flattening that input. The reason is I am going to create this model using ANN, right? So first image, whatever is there, I am going to flatten it and I am going to pass to the next layer, that is dense layer, right? Second thing is decoder is there, which is again dense layer, but it is going to reduce to the shape of that particular latent space. Okay, and then for again we are going to reconstruct it. Okay, so only that information is here. So what is happening here? Input dimension is 28 cross 28. I'm going to map it to the 64 dimension, right? I'm starting with 784 dimension. Then I'm going to map it to 64. Then from 64 again I'm going to map it to the 784 dimension, right? So while doing so, we have to train this model such that from encoder to decoder, I'll be able to reconstruct the same image. Okay, and now if I see the loss function I mentioned here is mean squared error. Okay, as I mentioned in the previous theory session that we just need to take the difference of output image and corresponding input image. If the difference is large, then that means reconstruction image is very poor. If that loss is getting less, then the reconstructed image and the original image are quite close to each other. That means quality of reconstructed image is quite good. Okay, and if I run this model, right, it will take some time. Then we will print the encoded images. So already is not there. It will take some time. So it will take a couple of minutes. Right. So what happened here is we simply try to map the we simply try to map 784 dimensional input image to 64 dimension, and from 64 dimension we are trying to create 784 dimension again. Okay. Now during that we mentioned that the loss is supposed to be minimum, and when it is going to be minimum, when the constructed image is quite similar to the original. Okay. Now you can see here in this loss is quite decreasing. You observe when you execute, the loss is started decreasing. Okay, so you can see here we have validation loss as well as the normal training loss here is not here for me as well. So initially the loss was 0.0133, then started reducing. In final iteration the loss is 0.008, right? That means in first iteration loss was quite more, but when we iterated through all these trainings, then the loss started decreasing. Okay, and as loss started decreasing, you can see the sample input and corresponding output. We can see this is how it reconstructed, right? So this was the original and this is the reconstructed, right? So likewise we can see here now with the minimal execution of this minimal training on this data set, we created autoencoder which can reconstruct the image. Okay, now this is the kind of vanilla autoencoder. Now what we have to do, we have to create an autoencoder which can perform the denoising of the image. That means given a noisy image, it is supposed to generate the clean image. Okay, as you mentioned in the previous session that what is supposed to be input here? Input will be noisy, grayscale, noisy image. Will pass it to the network, and output where we are going to calculate loss with original clean image. Okay, so that's what we have to do in the same network. That's it. Okay, so here second example is image denoising, where what I'm trying to do here again this pre-processing is there of the data. You can see here this is and where I'm trying to add some random noise in the image because we want to deliberately add noise in the image because we want our model to get clean image, so that we are going to add noise deliberately, and here we are adding noise in train and test data set, right? Then if I print these noisy images, it is going to look like this, right? So note that these are the noisy images created by us only, right? These are not originally noisy images. Deliberately we added noise. And now what we have to create, we want to create a model which is going to take these noisy images, and from these noisy images it is supposed to create the clean images. Okay. And you can see here, in previous case we used the ANN, but now here we are using convolutional neural network. Okay. You can see here encoder part is similar to your normal CNN. We'll be having input which is of say 28 cross 28 image. Then we are going to apply 3 by 3 16 mask in the first layer. Then 3 by 3 8 mask in the next layer. Right. So this is called as encoder part. Then we are going to create a decoder. In decoder, you see, I don't have normal quant 2D operation or quant 2D layer. What I'm having quant 2D transpose, right? So using that, I'll be able to create the image from this dimension. I'm going to double it, right, in every iteration. So here, if I run this cell and see the model summary, the model summary will be available after execution. Right. So you can see here again the loss is going to be mean squared loss, but validation data you see what I'm passing here. While training, what I'm passing all the noisy images and corresponding clean images. Right. Same way in validation, all the noisy images and corresponding clean images, because the loss will be calculated on those set of images. Right. And you can see in this case also loss started with 0.01, then becomes 0.009, 0.0094, and loss started reducing. And when we say loss started reducing, that means we are in the right direction of model training. Okay, so in this case, model is getting trained, and every epoch I am getting model which is a bit more accurate. Right? So at the end of this model training, what we are expecting, the model is supposed to generate clean set of images. Right? That is our ultimate aim here. Okay, so you see here, model is almost about to finish its training, and loss is reduced to 0.008. Okay, so you can see here, encoder part 28 cross 28 image is reduced to 14 by 14 and then 7 by 7, right? And what is happening in the decoder part? We have from 7 by 7 this image we got 14 by 14 and then 28 by 20, right? So one way we try to compress and other way we try to expand, right? And finally, if you see all these encoded and decoded images, right, you can see here those were the noisy images, and you can see almost the noise is being removed from all these set images, right? So if you see, these are the original images with noise, but now this is the reconstructed by the decoder, right? So this is one of the application of auto encoders. Okay, and the most key takeaway point from this auto encoder is this one, right? How these layers are being increasing the dimension or the resolution in every layer. Okay, fine. So execute this Jupyter notebook till the image denoising part, and let me know if you have any queries in this so far. Yes, any doubt in the implementation part of the autoencoder? Construction. Now, this is one of the network.
Sir, how to run it?
After once I used to come up there.
We looked at other. But that is stronger advertisement. Facing them is last week, exercise can
Okay, so I hope there are no more doubts with what my product. And you should continue when you use first to mass and you get mass generated losses. So it should not generate converted. The product is possible. So it can be and so then
when it is mapped 2 cross 2, then it is 6 cross 6. Is it that prediction that 3 cross 2 is equal to 6? Therefore, all the output at 6 cross 6 image. And one more doubt, sir. Like we have told that we are using that conversion instrument. We already have so many operators are already available. So that so many operators are already available. Why we are going to train the network? We have told that till the time we have to train the network, then we have all the accurate results. So, but for training all that part, definitely so much time will be consumed as far as the computational of all those there that rate that also takes so many times. But if already we have any operator or other operators are already available, so why we are going for such kind of computations?
Very good question. Why we are going from classical image processing to this deep learning, right? So you need to say. Look, first of all, the example that I gave you to demonstrate how an autoencoder works. We are not considering the application of autoencoders in very, let's say, realistic scenario. I wanted to showcase how autoencoders work. But you can appreciate black and white images getting converted to color image. That appreciation is there. But only thing is that in your case, the software operator, button, all these filters are there. They are enough for classical image processing. Those are classical algorithms where neural network or AI is not at all required. But this is only applicable for only that particular denoising or edge detection. But if you see in this case, that is only for if you see, if you let's say you want to blur the image. Okay, which operator use in image processing?
What we add noise also.
No.
What are you told that we are going to add noise, in which we will add noise, and then we will remove it. That function is also available in MATLAB also.
What type of noise also affect? If let's say simple paper salt noise is there, you have different filter.
Yeah.
If let's say there are artifact effects are there, you have to use different filters. Here, if let's say all type of noise is present in the same image,
Okay.
right? Here what happens? The training is trying to learn type of mask which is applicable to remove the denoise, remove the noise. Here, from the experimentation, you already know classical image processing. You already know with the experimentation, this is how this mask is going to work, and this mask is going to remove this type of noise. But here,
I just want to know the difference between convolution and deep convolution.
Deep means we are going to add multiple such layers. Deep. There are two types of network: shallow and deep.
Layers also added in convolution networks. Layers also available in deep convolution networks. But
More layers.
how will you differentiate that? What the threshold value?
Threshold value. Because you in deep learning, you will never see that this is a proof and this is the, let's say, theorem that based on that I can predict. Most of the things are completely empirical. Right? Whatever the problem size, if you are having very complex problem size, for that you have to create a very deep network. That is going to be deep network because.
And what about the what we have to compromise between those two metrics? Is the time to change the network and the complexity of the network as well as the accuracy of the output.
At the end, I want 4 items so that I can sacrifice it.
I will take around 1 year to get the accurate output. Then after that method is good.
1 year is also fine, but if you have multiple computational resources, overall time will be reduced. For example, take example of ChatGPT. You know how huge data set is there. If you try to run on your laptop, it will take forever. Right? So what they did, they know that huge data set is there. So what they did, they created a supercomputer. Right?
We are giving output as per the requirement of the user through ChatGPT. So how they understand it that what the requirement of the user?
I'm not getting this question.
And what I'm telling you is that suppose some thousands of iterations is required for providing the output. But if for accurate output, but if I am satisfied with that less accurate output, so it is not needed for go for so much iteration.
Exactly. Now you can see that model I was training, the every iteration error was, that loss was decreasing.
Right? You are not defining the loss concept.
Mean square error is defined, right? Here, you can see it. Mean square error that I explained.
Okay, mean square error. You are defining mean square error. Why you not use any other practice to define the loss concept?
Because here values are numerical, right? If they are, let's say, 0 or 1, then I would have gone for the other type of things.
Is that mean square error is the finance?
Look, you cannot say this is finance or that is finance. It totally depends on what type of application you're working with.
Yes, yes.
Right. In this case, it makes sense because our output values are the pixel values, those lie between 0 to 255. Right. So in that case, we are simply taking the difference and we are taking mean square.
So again, if I have to go for the RGB images, then also I will convert into ASCII and get the output, and then I will convert back to the RGB images.
There also mean square error problem. But let's say we are working on a problem. Let's say this image is having a cat or not. Here mean square error is not going to work because either value is 0 or then we have to go for the cross entropy loss. So it depends on type of problem you are solving, type of application you are working. Right. Coming to the point, you are saying that while model is getting training, I want to stop at a specific point. I don't want to go beyond that. If you are happy with 80% accuracy in your application, you can stop. Right. So when you run the model, it is going to tell you the accuracy also. Right. There are two types of accuracies are there in the model while it is getting trained. But that fine. That is done. Now, first let open this. You see, this executed. Yeah, this. We are not. Let's execute this. Let's say run on this. So let's see now here when this model is going to train. Let's see here why model is getting straight. So we get accuracy.
How many of you learning this?
Again, what this? What we do? Draw graph process.
But we not maybe years in the section.
Obvious, right? So you start with the first iteration, you print the accuracy. Accuracy is let's say 50%. Next iteration, you got accuracy 70%, 80%. So accuracy goes on increasing. After some point, it will be saturate. It is not going to be beyond 95%.
So that's what your considerations or your expectation, we can stop it.
Not my expectation, rather I would say model's behavior. If model accuracy goes on increasing,
Right now, started, we are getting a linear type of
linear in the sense when it is going to be constant.
yeah, constant.
At that point, you can go for 100 epochs further. It is not going to improve the accuracy. That is going to be stopping. Okay. Now you can see here what I was saying to sir that this question is when to stop the model training. Right. I'm not sure whether it is visible for you or not. I'm trying to zoom in, but it's
50% right now. The topic is showing.
is it visible now? Okay, now at least I think you can see this accuracy. Right. So here it is only loss information. So you can see in every epoch the loss is reducing. What this is meaning to us is that in every epoch model is getting more insights about the data, it is learning better, and loss is consistently decreasing. And there will be some point we can see here. Earlier the loss was decreasing with the quite big magnitude, but later on the loss is reducing by a very small magnitude. What does it indicate? Now model training is saturated. Now how many times you train it or how many epochs you go on to train, the accuracy is going to be or loss is going to be the same. So that is one signal for us that you have to stop for the training.
So at the same time, I just calculate the mean square error. Once I find that the when
that is what it is predicting. Mean square error.
that is predicting. So as the value of mean square error is reducing, then we will stop this.
Reducing consistently means you don't have to stop, but it is being constant.
Okay.
Like not changing with the much magnitude or it is fluctuating at the same point, then you have to stop. Fine. This is all about the autoencoders. Now, the major part that is missing is generative adversarial network. Okay, that is what I'm going to start now. Okay. So agenda is going to be first of all we will discuss basics of generative adversarial network, and that is a very important network, and that is used in most of the state of the art networks or the application domains where it is proposed. Okay. So the title of generative adversarial network is there. So there are three keywords are there. First one is generative, and by this time you know the meaning of what is generative. Okay. So models are not going to simply classify or regression models. They are going to self-generating something. Okay. And then we have adversarial world. That means we'll be having two models. They are fighting with each other. Right. So fighting in the sense one model is trying to fool other, another is model is trying to become more intelligent. Okay. So that kind of computation is happening between these two models. That's why the word adversarial is mentioned. Okay. And the third one is the network that is coming from the deep learning. Okay. So let's try to understand. So for the simplicity, you can see there is one picture shown here. These are the faces generated by this generative adversarial networks, and these are the faces of the human which are not exist. Okay, so they don't even exist, but still we have this image, right? So this is one thing, and let me explain what is this generative adversarial network. So as I mentioned, there are two class of models will be there in this network. One we are going to call it as a discriminator, and other is going to be referred as a generator. Okay. So whatever we have learned so far, there we train only one network, right? In normal KNN we created to classify digits. In other network, we try to use convolutional neural network, which is also classified the digits. We used encoder. There also we had only one model, which is going to convert your noisy image to clean image, right? But now here we are going to club two models together, right? And they will be trained in adversarial manner. Okay, and out of them, one model is referred as a generator, and other is referred as discriminator. And discriminator model that we are already familiar with, that is nothing but your simple classifier. That sort of model that you have already learned, already observed in that CNN assignment. Okay, so what it was doing, simply taking input and it is trying to classify in one of the class. Right, that's why it is called as discriminator. Like normal binary classifying neural network is called as discriminator. Right. So in this we are having two models: discriminator that is represented with the D and generator that is represented using the letter G. Okay.
Opposition is from distributed. Opposition, the concept is for
This one?
what is
No. These I can explain. When you once you go for the training these models, you will get to know that why these models are fighting with each other. Okay. So we have discriminator model and generator model. Generator is going to create realistic images which is going to fool the discriminator, and discriminator is trying to classify them such a way that it is getting more intelligent. Okay. So just hold on for a few minutes. Like when we discuss about the actual model architecture, then we will be able to distinguish between this discriminator and the generator. Okay. So you first of all think here the architecture of
Okay.
okay. Let's just focus on this part. Right. So here we have a generator G. We have a model generator. We are going to call it as a G. Right. First, let me tell you what is purpose of generator only. Once you understand the purpose of generator, then we move on to the discriminator, and finally we club these things together. Okay. So here in this block, it is depicted G stands for generator, and we have upward here that is D. Right? It is not a discriminator, it is normal data. D stands for here, capital D stands for data. Here Z stands for a random value we are picking from the Z, any random sample. Okay. So here Z stands for random values, set of random values we are picking. Right. So we have random normal distribution from which let's say we are taking 100 values. Those 100 values will be placed in the column vector. Okay. Now these column vector will be passed to the generator, right? And generator is going to map these values into another values, that is G of Z. Let's say G stands for generator is a function which is taking input as a sample from this random distribution and is going to map to G of Z. In this point is clear. A random vector we are picking that we are going to pass to this neural network, that is G, and it is going to map into another distribution. Okay. Here Z, capital Z stands for random distribution, and the map distribution is going to be D dash. Okay, and find here, this is the original data, that is D. Okay, now let's suppose we have all the human faces present in here, right? The faces which are existing. Let's say we have data set of, let's say 10,000 human faces that we are going to store into this particular D data set. Right? So when we consider it as a data set, it is supposed to have some distribution, right? So it is having, let's say, D distribution. This is given set of images. Now generator's job is to take random noise from here and it is going to map into some other domain distribution, that is D dash. Right? Now the condition for generator is it has to make D as close as possible to D dash. Read that statement very carefully, because that once you understand this statement objective, it is very easy to understand the behavior of this GAN models. Right? I repeat, D stands for given data set. Let's say set of faces, human faces are there. Okay, which is going to follow some distribution. Then from random distribution, I am going to pass input to the generator. Generator is going to create another set of output values. It is also having some distribution that we call as a D dash. Now, generator's job is to match the D dash as close to D. Now think on what will happen if D dash and D are close to each other.
there is very less losses. They are going through this.
Okay. One more thing. this noise is random noise. It is not added with the input noise. It is simply random noise. In short, you are defining a Python function, NumPy array, in that you are taking some random 10 values from the random distribution, random normal distribution. Right? It has nothing to do with your data set what you have as of now. Randomly take 10 values, pass to the network. It is going to create some values here, right? And this dimension and this dimension are going to be same. Now, objective is make D as close as possible to D dash. My question is, what happens when D and D dash are very, very close? D stands for input data set whose distribution is there, and D dash is a generated images distribution. If both distributions are similar, what does it mean?
100%.
Okay, accuracy is another concern, but can I make the statement that images from D and D dash are going to be the similar if D and D dash are quite close to each other? Okay, for example, I'm not sure how to draw here. Let's say I am going to have one distribution which is going to be like this. Okay, so this is one distribution.
You take these at first, then we
I explain this part when I. Okay, so let's say this is one distribution, Gaussian distribution is there, and which is another distribution. Let's say this is right, which is not close to 0. This is at 100. Okay, this is at 100, and this is saturated at 0. Now these distributions are not same, right? One is normal distribution, other is quietly different. But if two distributions are overlapping, right? So let's say I have another distribution which is like this, right? It is quite matching with each other. Now if I take random samples from both the distribution, they look like from the same distribution. They whatever I am taking random values from this distribution, those are going to be quite similar. Unlike if I'm having these two distributions, one is like this and other is like that, so values will be of different range, right? Now, what it is saying, generator is going to generate images such that they are quite close to the images that are present in the D. Okay, so this is nothing but the objective of the generator. Generator's objective is take random input and produce the images that are quite close to the original data set. Okay, again, just I'm telling that I have not described you how to do that. I'm just telling you what generator is going to perform. Okay, we'll see how generator is going to do that after we discuss the entire model. But as of now, just try to accept that generator's job is to generate output such a way that it is going to match the distribution of your original data set. That is the key takeaway from this slide. Okay. I can see your faces. You are quite worried that how it is possible. Random input I am passing and I am expecting it is going to look like the original data set, right? So just bear with me for a few minutes. You will be able to understand. But meanwhile, just try to get familiar with this.
D dash should be as close as possible to be the solution.
You just get familiar with these notations meanwhile. What G stands for, what X stands for, what D dash stands for, and all these notations. Because we are going to use those notations very rigorously. You can take any set of images in X. Let's say you want to generate new human faces, you place all images of human faces existing in the X. If you want to generate vehicles, place all the images of vehicles in X. Right? The keywords are here, notations are D. D stands for distribution of input data set. So whatever images you are going to place here, that is going to be its distribution is D. Z is a standard normal distribution, capital Z, and Z small z is a one sample we are taking from that normal distribution. That sample will be passed to G, and G is going to map small z to G of Z. Right? So for all z, small z we are going to pass here, it is going to create a distribution here that we are calling it as a D dash, and the objective is to make D and D dash closer to each other. Okay. Okay, let's try to understand how it is going to happen. Okay.
Try to make that D dash into D using discriminator.
Exactly.
Any standard image can be generated, sir, from random data. Like if I want some celebrities photos, I get
That is the first thing you have to accept. Right? It is going to generate, right? But how it is going to generate, that I am going to explain. Okay. So this is the network here. One is called as a discriminator. Let's try to understand what is the role of discriminator. Okay. So here on left hand side we have latent space, that is what I said, that is random values we are picking up. Here we are having real samples. Okay. Let's say for this particular presentation now I'll be considering, let's say we want to generate sample images of that fashion in this data. Tie, coat, shoes, those images are there. I want to generate similar images. Okay. Now in original data set, what you will get, all the images right now we have that are going to be placed in the real samples. Okay. Now observe here how this model is being trained. This model is having two neural networks, one is generator, other is discriminator. Okay. The discriminator, which is going to take input from real data set as well as from the generator. Okay. So when I'm saying here real samples, that is data set available with me. Okay. And generator is going to generate new samples. Right. Now here generator is going to take random 100-dimensional vector suppose, and it is going to map into generated fake samples. Now these samples are going to be of same dimension as real samples. Let's say in fashion image I am having the data set of size 28 cross 28 images, right? Real. So generator also going to generate 28 cross 28 images, right? But those are going to be initially fake, because if you pass random value to the network and do the multiplication in the neural network in forward propagation, it is going to give you some random values in that image, right? So in short, that is going to be kind of garbage image, right? Which is not having even that shoe, tie or something. Okay, in initial phase. Now, what is job of generator? Take random value vector, pass it to the network and create a fake image of 28 cross 28. In this point, is it clear what generator is going to do? Now, whatever image generated by generator, we are going to call it as a fake image, right? And the images that are from the real sample that we have, we are going to call it as a real images. Right? Now, how many classes we are having? Two. One is fake class, other is real class. What is job of discriminator? Discriminator two, his job is to identify whether the image is from real dataset or fake dataset. Okay. Now we will label them. If the image is generated from generator, then we are going to label it as 0. And if the image is coming from the real dataset, we are going to label it as 1. Because at the end, it is simple classification problem, whether it is coming from real dataset or fake dataset. Now, for real dataset we have label, and for fake dataset we have label. Now, we will train discriminator to identify whether it is coming from real dataset or the fake dataset. Okay. And now, let's say if discriminator is making some mistake. Now what will happen? Error will be back propagated to the discriminator, and discriminator trying to update its weight. Right? So initial phase, what will happen? The images generated by generator were completely disturbed. Right? So obviously discriminator is going to easily identify, easily learn that thing. Now gradually, what it is going to do? We will be having generator. Okay. So this is the neural network that I was talking. Zoom in. Right? So let's say we are taking this random noise and then we are passing to the neural network, and you can see the generator is going to generate fake samples, right, which are quite disturbed. Right? Again, initially also you will not even get the picture of t-shirt or any of the object in the image data set. It will be kind of garbage output it is going to give you, right? But gradually once we train, it will be able to generate a new set of images which are going to look like images from fashion images. How? So first of all, understand this neural network. You can see here output layer is of 28 cross 28. Why? Because input sample is of 28 cross 28, so we have to match that dimension here. Okay. Now, in case of discriminator, we have output layer is having only one neuron. Why? So, in case of discriminator, I am having only one neuron at the output layer. Why? 0 or 1. That's okay. So this is the network. Now let's try to understand how it is getting trained. Okay, so you can see here I'm having random vector noise vector passed to the generator, and this is going to be initially, because randomly it is going to generate any image. We will label it as 0. That is fake. We will take input from this real data set, we will mention it as 1, and we will train this discriminator. Right? So how we are going to train? What kind of loss function we have to use here? Output layer is having only one neuron. Sigmoid, right? Or in short, it is going to be binary or cross entropy, right? So at least binary classification is there. So that sort of we are going to use that output neuron is going to have a function as a sigmoid, and based on that we are going to calculate loss. Now you can see here, initially discriminator is going to be easily able to identify whether it is fake or real, because real images are going to have some specific pattern. The fake images are complete disturbed pattern. Right? So discriminator is able to classify here whether it is fake or real. Now next time what we are going to do, if discriminator is going to make error, it will be back propagated accordingly to the discriminator, and it is going to update its weight. But you see here, next time what I am asking here. Next time, whatever input generated by generator, I am passing it with label 1. Though it is a fake, but I am telling discriminator that I am trying to fool the discriminator. Okay, this is the real one. Right? Now what will happen? In first iteration, discriminator is going to easily understand whether it is fake or real. But problem is that in next iteration, what I did, I passed the fake images, but I labeled it as a real one to try to fool the discriminator. Right? But discriminator is intelligent. What it is going to do? It is going to say, okay, it is not a real one, it is fake. Now, input label is 1, output label is, predicted label is 0. So there is huge loss. Right? And based on that, now weights of the generator will be updated. I repeat the statement. In first iteration, what we did, normally we train the discriminator with artificial images with label 0 and real images with label 1. So discriminator is going to classify. But next time what I did, instead of passing the generated image as a label fake, I passed it as label real. Right? In order to fool the discriminator. But discriminator is not that fool. It is going to tell you that, okay, this is not the fake image, right? Sorry, this is not the real image, it is a fake. Now, the output label is 1 and predicted label is 0, because discriminator told that it is a fake. So there is going to be loss, right? And this loss will be back propagated to the generator. Now generator is going to update its weight in a such a way that next time I'll prepare more realistic image. Getting it? So in first iteration, it is going to pass this image, but discriminator is telling that okay, this is the fake image. Now this feedback will be gone to the generator, and generator is now updating its weight in order to next time make more realistic image. Right? Next time generator is going to make more realistic image, and during that time it is going to again pass with label y equal to 1. Right? So this training is happening in alternate fashion. First, discriminator get trained, then generator. Discriminator, generator. And during this process, what is happening? Discriminator is trying to be more intelligent so that it is going to classify the images which are fake or not. And generator is going to try to be more intelligent in a such a way that it is going to fool the discriminator. Right? So this process happens alternately.
This is opposition.
Right, because generator is trying to generate new images in a such a way that discriminator is not going to differentiate. Why? Discriminator is getting more stronger to identify whether it is real or fake. Right? And both are training in adversarial manner. Right? One iteration is going to train discriminator, other iteration we are going to train generator. And alternately we are making both stronger. Now finally what will happen? Now generator is going to generate new set of images such a way that now discriminator is not able to distinguish whether it is coming from real one or fake one. Right? So after we train multiple iteration, then generator is going to become more, because every time it is going to pass fake images with label 1, loss will be high, and that loss will be back propagated to the generator. And generator is going to update its own weights and is getting more and more create more and more realistic images. And if it is going to create more realistic images, right? For example, here, if these images are more realistic, of course, we have already the realistic images, but even generator is also able to generate the images which are kind of similar to the real one. Now, what will happen? Discriminator is not going to differentiate whether it is a real image or fake image. And when discriminator is not able to decide whether it is a real image or fake image, then loss will be what? Or what will be the output of discriminator? 0 or 1?
If it is not able to classify.
Yes. I repeat the statement. If it is not able to classify, what will be the probability of being class 0 or class 1? 0 means it is fake. 1 means it is real. But it is not able to distinguish. Then what will be the probability? Yes? Somebody? Huh?
Then confused state.
Confused state. What is that confused state? What is the, let's say I am tossing the coin. I don't know whether it is going to head or 0.5. Right? So that means when discriminator out giving probability as 0.5, that means it is not able to distinguish whether it is real or fake. So that when the discriminator outputs become 0.5, that means both the neural networks are trained in a such a way that now generator is going to generate new images which are going to be more realistic. Right? Now when this is going to happen? When generator is going to generate the data which is of same distribution of the D. At D is here we are having all fashion data, and here we are having all the generated samples. When both the distributions are matching, then we can say the images generated by the generator are realistic. But always remember that the whatever images are generated by generator are not present in the D. Right? It is not copying from the D. It is following the pattern, and accordingly it is going to generate new set of images. Right? That's why you see here the images that I showed here, those are generated by generator. Right? So they are not real human face. Right? These people don't even exist. But the generator model created these kind of images, right, which are kind of similar to the original data set.
If the features are not
Exactly.
not the features are not. For example, for t-shirt
Features, right? Feature is a single entity you are talking about. But if I consider distribution is covering all the right, so feature rather than I'm making generalized way, it is a distribution.
Can this be compared to a physical scenario where some police is trying to investigate someone? Sketch making is called a crime, a criminal.
No, in sketch making, now you have to give input. The eyes are not like this, the shape of the face or like you are going to provide the exact.
No, no, it's like that will be our input, whatever we are thinking.
Then we have to make specific input for that random vector. It is not input.
It's the new image. I don't have any creating something which does not exist.
Exactly.
So that cannot be managed.
But no, while matching, you are specifically telling that I want this type of nose, this kind of facial, this complexion.
Got from this similar face, that application is something for that.
Applicable, but not the basic naive GAN, I'm saying. Maybe we can modify this GAN with, let's say, rather than give random noise, you'll be giving some parameters random. Okay, for let's say, for white complexion, you are giving some value, right? Maybe for oval shape face, you are giving some value. So, yes, so that kind of extra information you have to give. Right, that is, I can consider maybe the conditional GAN.
But then can that be application of GAN?
Yes.
Then
Only the vanilla GAN cannot be used for that. You have to, what I can say, tune your GAN in such a way that it also accept not only the random noise, but it also accept these parameters.
What is the use of this getting these pictures? What is where this will be used and where is the application? Then this if I get these pictures of what is the use of this?
I can create some criminal profiles. I can.
for various purpose it can be
No, wrong usage I'm saying. Yes. You can create a fake ID of that person.
For fake passports.
the person
But
which doesn't
that is not
exist.
supposed to be the application, but people can use of that. But here, maybe you can create avatars. Right. For example, you want to hide identity of some person. These images can be used. Okay. So this is one domain. I'm just telling you how we can generate. Now same concept will be applicable for any other domain. You are talking about the music generation. Here from random noise we'll be able to generate music. Now you tell me what will be there in the D. No, D, not set. Actual music. Let's say here I place all the ARM music, the pre-process and according to the data I place here. Then from random noise, I'll generate some random music, which is not going to be kind of, we can call it as even music. Initially put this simple noise. That noise gradually becomes music, right? Because the discriminator is going to tell you whether the music is from the real data set, music file, or from the fake that is generated by AI. Sorry, generated. Right? If discriminator is trained on that first iteration, later on you will be passing this noise and you will tell the discriminator that okay, this is real. Now discriminator is going to tell that no, it is not real, it is fake. That loss will be back propagated to the generator. Now generator will update its rate and next iteration it is going to create more realistic music files. And if you go on creating this, later on there will be a point the discriminator is not going to distinguish between the whether the music file coming from ARM and music folder or maybe which is generated by the generator, right? And at that point, discriminator's output will be 0.5, right? And that means your model is trained well enough to generate new files. Okay, and always remember that whatever is generated here is not the exact replica of something from here.
In case of binary classifier, it's always either 0 or 1, but this is a discriminator, therefore we can get 0.5 also as a value.
Output is 0 or 1, but first we get probability, right? You have sigmoid function. Sigmoid gives you value between 0 and 1. If it is crossing 0.5, we classify it as 1. If it is greater than 0.5, we classify it as 0. But first we get probability and then we apply threshold. Right? So if probability is 0.5, that means model is not able to distinguish between 0 and 1. Right? Okay, I'll just display this particular slide for few couple of minutes so that at least you will be able to understand the process. I see some cases are still confused, they are not able to digest this discriminator and generator. But initially, it is quite difficult to accept that how it is going to create the new images from the random. That is going to be the first question always. But if you see the training process, then you will see how error is back propagated. Okay. For some time, I'll display this slide to you, and if you have questions, let me know.
It's interesting to see an application that's actually doing this. So we've given random real set, and then you went generative.
It's an application based.
Then that would be interesting to see how it is actually done.
We have this same assignment. Okay, in hands-on session, we are going to take the same fashion images or digits. You will see that Generative is going to generate new set of images which are not present really in the real data. Okay, but I cannot create very huge network because it will take forever to run with available free resources on Polar. Okay. At least I will be able to demonstrate with the fashion image data set. Then you will be able to appreciate for the other data sets.
So chat.
So, sir, right now, what is the application for GAN right now? Where are we using it?
Let me tell you the problem statement I am working on. Let's say you are working in healthcare data sets. Okay. So data set is going to be imbalanced. Right? Let's say you are working on diabetic patients data sets. Diabetic.
You're not very clear.
Okay. So ma'am is asking about the what are the real applications of this GAN where it is going to be more useful. So I was saying that healthcare data set. Okay. So let's take a data set of cancer. Cancer cell images are there, right? So if I take, let's say, visit the cancer hospital, right? If you see out of let's say 100, there are going to be barely 5 to 10 people who are actually suffering from cancer. Or in general, if you see in our society, out of let's say 1 million, there are going to be very significantly less number of people who are actually suffering from cancer. So when you have this kind of data set, tumor data set, you'll be see that majorly the data set is having non-cancerous data points. And there are going to be very few points where the actually patient suffered from the cancer. Okay, so let's take we are having cancerous skin cancer images are there, right? In the data set, whatever we have collected, maximum images will be of the patient or the person who is not having cancer. And there are going to be very less images where you will be able to find out the images are with the skin cancer. Okay, now the data set is imbalanced. Okay, maybe I'm having 10,000 images of patient whose we captured the skin, we have taken the skin photograph, and out of 10,000, only 100 images that are related to the skin cancer. Now data set is hugely imbalanced. That we have non-cancerous images are very huge in number, and we have very less number of images which are related to cancer. Now, if we try to train such models, it will be always biased towards the non-cancerous patient because we have very less amount of data related to cancer patient. Right? What we have to do? I have been checked. So in this case, what happens? We want to create our own data set of cancerous patient now because I have to balance the data set. If I don't balance, then model will be always biased towards the non-cancerous patient and you will never get the desired accuracy. And this is a very critical application where even one misclassification or false positive also it is going to cost life. Right? So here, in order to increase the accuracy of your model, first of all, either you have to find out the hospitals where the cancer patients are going to be there, and specifically with respect to skin cancer, Even in skin cancer, there are many such categories, right? So that category is very rare. And for that rare category, you don't have enough input images. And that's why you are not able to create machine learning or deep learning model, right? So in that case, in order to create balanced data set, you can synthetically generate these cancer images, right? Using the generative. So how will you generate them? You will be having, let's say, 100 or let's say 1000 skin cancer related images. I'll put in the D, right? Then I'll label them as y equal to 1 initially. Now I'll ask generator to generate the images of skin cancers, right? It is going to initially generate some garbage. Then I'll pass this input to the discriminator. Discriminator is going to get the input and it is going to classify it as 0 or 1, right? So according to discriminator is going to update its weight. And finally what I do, whatever image generated is there, I label it as a 1. Though it is a fake, I call it as a real. And pass it to the discriminator. Now discriminator tells that okay, you are telling it is real, but I am saying it is a fake. Right? So loss will be huge and loss will be back propagated to the generator. And gradually, with this adversarial manner, generator will be able to generate images such that it is going to fool the discriminator. Now, and by doing so, images generated by generator are quite similar to the original images. So one application is balancing the data. And that is very, very critical in case of many diseases because the patient number is less, but the disease is very light. Okay, and in that case, we have to create models very accurate. And if you don't have data set, no matter what sort of neural network you have, your accuracy is never going to be increased. Okay, that is one application for this what we call as a synthetic image generation. Okay.
How to design this?
It is simply classifier. Simple classifier. Right. I will explain with the code also.
So there are or really classified because it is.
No, nothing with respect to the power of that particular distribution. It is the neural network. Like normal convolutional neural network, finally it is going to tell you whether that particular image is from real or fake. That's nothing special about that. Only thing special about the generator, which is going to map that 100-dimensional image to 28 cross 28. Upsampling.
Generator for designing.
Now once model is trained, discriminator is saying 0.5 output. Simply you plug out the generator model, pass the random value, it is going to automatically going to generate the real images. Once training is over, we don't need discriminator. We are only care about the generator now.
There will be standard model for generator and discriminator.
No, there is no. Always remember, in deep learning, nothing is standard. Everything is empirical. Meaning is that, for example, you have studied in the CNN maybe VGGNet, right? ResNet. If you ask, right, VGGNet is let's say designed by Google, ResNet is designed by Microsoft. If you ask them prove why this is working with highest accuracy, why you design this only 152 layers, they will never be able to prove that. They'll say we experimented and this suitable configuration that we found.
Is there any standard how to design next one like for BGP we know I will go your model how we are going
Those are also first thing, those are also not standard just because they found the optimal parameters and optimal layer and optimal configuration. That's why we are referring it as nothing. It is based typically on your or simply telling you I can put here in case of generator, I'll copy paste the layers of the resonators. I'll copy paste the layers of the Google name. Could be anything, right? So it depends on typically what application you are working, right? So always what we try to do is that we simply try to borrow learning from other already trained models. That is called a transfer learning. Okay, but these networks are quite different compared to normal classifiers, where we can already easily transfer the learning from other application to our application. But here, if the input set itself is data is going to change. For example, here I am talking about the fashion data. Next time, if I am talking about the let's say human face, context is completely different, right? So in that case, maybe some information can be borrowed from other networks, but up to what extent? Because context is completely different.
So every application is unique in itself.
Yes, I would say, because ultimately the distribution is going to be different for all the different data types.
This is much more better than those networks, because we are modifying and we are getting something new, like.
Yes. That is nowadays that's
More,
elegant compared to the previous.
and real-time examples is really required.
Yes, because from 2012 to 2018, people were doing the similar classical deep learning, classification, regression, object detection, object recognition, those sort of things are there. But now 2018 onwards, if you see, many companies are simply adopting the generative AI concept to solve different problems. They are not even releasing how they are doing. Like, for example, I was saying music generation. They don't even release how they. Not exactly the GAN. They are not expert in the language models. But perhaps the upcoming speakers in upcoming session they will elaborate more. But I would say the umbrella of generative AI inside that it falls. Right. I'm talking about only the from image point of view. They are the expert in the NLP. Maybe they'll be able to explain the chat GPT in a better manner.
Does not generate new contents. It takes content from all over the web and then give you a summarized way of that.
No, that is not true from my point of view. It is, yes, because if it is collecting the data, it is not search engine is there. It is trying to give you.
But it's not
But
generating
if,
on
no,
its
but
own.
if I ask, let's say, write a program to sort in ascending order using quick sort and same input passed to the bubble sort and sort in descending order. This program doesn't even exist in the internet.
But
That is crazy program, useless program is there, but still it's able to generate. Right. So collecting information and presenting in front of you is the it is generating, right? For example, look at what is use of the program that I'm saying. I'm asking write a program using quicksort to ascend ascending number, right? And use bubble sort to again represent in descending order. What is use of this program? Nobody is going to use, but still I'm passing this input, it is able to generate. Right. So it is based on generating.
Maybe this is for images point of view, but for ChatGPT was more on text. Images also required.
ChatGPT I have never tested for image. But I think some premium version maybe it also support the image search or image editing or image captioning. Look, on today on internet you will find all these applications, right? Like here, you can see here AI art generators are there where you are going to pass the information in textual format and it is going to generate the images. And then I tried to test this thing 2 days back. Okay. I'm not sure whether it will generate or not. I have not tested it. I just mentioned cat is playing cricket. Okay, so Google Bard is there. Whether it will be able to generate something it is generated, not much relevant to the cricket. But cat is there and it is playing something. Maybe that is not the intention of this Google Bard. Maybe we have some more. I don't remember the name. With journey or something. Right.
But then using GAN, we can again generate lots and lots of data sets, which could be very helpful in the
One of the
training.
applications.
So research purpose it is quite useful.
Yes. Yeah, it is going to ask you money. Let's register it and check whether it is going to allow me. Because if I remember earlier, this mid journey was giving the at least test this particular thing.
Then, sir, the way any of the plagiarism they detect, the AI generated content and the original content, what is the process behind?
Some language models explore.
But they are using something of the
So
sort.
something is that like cat is playing cricket, so it is showing baseball actually.
Not
Cat is trying to play something here.
But 50% of the content.
Yeah, so maybe right now the model is not, or maybe the for trial version they are not giving us the full fledged model. Something. So you can type weird thing and it is trying to generate. Right? So you can see it is generating from the text. Right? So now you can imagine. Now creativity you can imagine, right? So earlier we had to use the sketchers, drawing experts. Now simply you are saying that okay, I want to create an avatar for let's say some actor, right? Or you want to create some crazy imagination, you just paste here and accordingly it is going to. I have seen some YouTube channels, they are creating the fairy tales, right? Using text, generating the fairy tales for the kids. That fairy tale will be provided to the input to the animated generator. That text will be given to the that generating the animation. They are clubbing this thing together and creating video. They are publishing. Immediately the monetization is started. That I don't remember the name of the channel. I observed that very few months back, and it was quite sound. Right, you don't even see that it is created by AI or by the human. That accuracy is there. Now you can see how people are earning from these tools also. Okay. So
this is one of the applications of
one of the applications, right?
Suppose that you give your picture as standing and you write you are running, so will it converting in a running position?
That way I have to train. Every time I have to give the input as I told you, to give input image to the model. Some models are going to make it 3D avatar for it. And whatever movement you are going to do, the same movement that particular avatar is going to do.
While training, you have to give your running images also.
Because
how that person is looking.
yes, so that information is supposed to be passed by training. Okay, so whatever you want, that sort of information at least present. Right.
So what would be next application besides generating data sets and balancing data? But this is also itself very good application which
that is one application that I remember because we are focusing on that project now. Okay, that's why I recalled you. Other data you can see not only the simple image generation, text to image is there, image to text is there. Right? So my image you are putting into as an input, it is giving you all the details about what is there in the image. Okay. So that way, maybe you are going to pass the static image, it is going to create a video out of it. Right? You will pass, let's say, Prabhudeva is dancing. Okay, in one video. You are passing your image, it will replace the Prabhudeva and you will be dancing like that. Okay, so many such applications are there. Image morphing also you can consider, but let's say the avatar is like Prabhudeva and the steps are like you. Okay, so you can imagine anything that you have to generate, right? So if you have to generate new information, then always remember that there is going to be a generator and this. Okay. Again, this paper, what I am talking about, you now talk right now, that is GAN, was published in 2014. Later on, many such upgradations are there, right? So recently that unit architecture in 2018 or 19 proposed, right, in which we have this convolution 2D transpose operation of sampling operations. Okay. One application what I remember is generative AI is converting paintings into real life images. Right. For example, somebody painted, right? So next painter is there who painted some scenery. That is going to be using the brush strokes, but you have to convert that into realistic images. Like some scenery is there. Let's there is a lake, there are trees, mountains are there. So that is painting. But now it is going to look like just like you captured from your mobile device. Right. So that is called as image to image translation. Okay. Other thing is that let's say you have picture of zebras, you have pictures of horses, right? So you simply convert horses into zebras and keep all the background images are the same. That is also image to image translation. Okay. Other applications like you normally let's say simply draw some sketches, right? So what I can do, I will create a data set which is a normal drawing by let's say very poor artist from my side. I'm going to draw let's say flower like this, something circular. I'll create such kind of images and I'll pair with the real images. Right? Let's say I draw flower by pen and I'll create the pair of that normal hand drawing with the real flower image. Right? And if I train this model with this pairing, what will happen next time if I try to draw anything from normally using pen, it is going to create realistic images. Okay, so one way you can say that I can do the let's say creativity in me by just simply drawing with a few stroke and be able to draw very good quality images. Okay, so there are some many such applications are there. Okay, let's run this particular network first so that go to that folder and open that GAN folder and open this Jupyter notebook DC GAN. Okay, so in this DC GAN, it is provided this animation where in how you can see after some iterations, the generator is able to generate images which are being more realistic. Okay, so for that reason, again, connect to this particular instance and select the runtime type as T4GQ. Okay, or else it will take a lot of time to train. So open that Jupyter notebook and run these cells one by one. And first implement, I'll show that output to you how it is going to change. It is going to take quite time in order to train. So first of all, run all the cells, then I'll explain step by step. Because for training it is going to take a bit time. So it is better to run first. Okay, so you can see here, I have created here two models here. One is going to be generator and other is going to be discriminator, right? So initially it is going to do some pre-installations and whatever the data loading thing is there. So here what we are doing, we are loading the MD's data set, right? So the digit data set, we want to train GAN such a way that it is going to generate images of handwritten digits. Earlier what we did, we try to denoise these sort of images, we try to reconstruct those images, but now we are going to generate those images. Okay, and that is using generative adversarial network. So you can see here, generator model is there. So you can see here, input is of this we are taking, input shape is of 100, right? Then we are going to reshape it to 7 by 7. Then we are going to 2D transpose it, so it becomes 14 by 14. Again, we are going to make 2D transpose, so after that it is going to be 14 by 14, right? So generator is going to take a vector and it is going to convert 7 by 7 image, 14 by 14 and 28 by 28 image. So this is how the generator is going to be designed. And normal, your discriminator is going to be like normal CNN layer. So we will be having convolution layer, then dropout, leaky review, convolution, and finally the last model, the last layer will have only single neuron. Okay, because we are going to perform the classification. Now, can you tell me what is going to be the loss function for the generator, or how we are going to calculate the loss for generator? Discriminator, you know, either 0 or 1 will be the value. Question is, for generator, what will be the loss?
Last year is 0.
How will you calculate loss for generator? Yes?
Entropy.
Entropy. What is the generator's output?
Initially it is 0, then it would be gradually coming out to be 1, 1, 1.
No, generator's output is going to be the image, right? Generator is going to generate image, not the label. Generators.
How, what is the error and how correct it is, that will be decided by this.
Error, if you see, when error is getting back propagated, when discriminator is going to make mistake. So loss will be calculated there only. Okay, so at the generator we are not calculating the loss. Okay, we are making generator intelligent enough to create new images, but we are not calculating loss at generator, rather than we are passing this fake image to the discriminator, and discriminator is judging whether you are able to, the generator is able to generate realistic images or not. If not, the loss will be back propagated to the generator. Okay, so in both the cases, the loss will be the cross entropy, and you can see here in the training checkpoint folder will be created. In every epoch, what type of images it is being generated, it is mentioned here. So you can see here at this particular epoch, the generated images are going to look like this. So obviously, in first epoch itself, it is not going to generate the realistic images. As you training gradually proceed, and finally the loss becomes 0, or that probability becomes 0.5, then you can say here the outputs are going to be realistic, right? So there will be one training checkpoint folder in which all the images with respect to every epoch are going to be created, right? And finally, it is going to create a zip file based on all the output images, and it is going to display you what happened from first epoch to last epoch. Okay. Yes. I want to order food. Return journey. Food. Return journey. So what is the address?
I have sent you the one.
No.
The
Building name.
the
Zomato accounts inside. Or at you.
we will coordinate the task. So take this.
It takes some time for training.
I will give them some exercise related to article discussion. Article discussion is research paper discussion. I just have to give them the research paper. If you want that, I can take it. The address is there in the morning message. Below the map, I should be the concentration. So very good afternoon. As you all have seen the schedule of the FDP, there is one hour session on article discussion every day. So time in the schedule I have given as 3 to 4, but we will manage as per the experts. If expert wish to continue, I will be taking at the end. The meaning behind it is we have formed 11 groups of all the participants. Considering the same colleges faculties into one group. And then we have some papers for your latest research papers on generative AI. We have the printouts, we have already prepared it. And per group, we will give one paper that I will be distributing today itself. And then we have 2 standard formats of ATAL in which they have given certain points to take up from that paper, like what are the implementation methodologies used, what are the key takeaways, how it may be useful. So that you have to do the findings from the research paper. And from tomorrow onwards, we have 50 days for it, and we have 11 groups. So from tomorrow, in that 1 hour, you have to present it, and there are marks on it, and then mark sheet is uploaded on the ATAL portal on that your presentation. And on Friday, final format is to be submitted, which I will be giving you blank today. I will give you the blank format for it. And from tomorrow, you have to present it per group, and one can present. So these are topics and you can sign it, and I will give the paper also at the time. And so special signature sheet or the sign sheet and that is for the paper and the finish. Pardon? Neon generating, not on air generating. Latest paper that here they use journal links. So if you are in some data center, you have other members which you can current. It's a 5 to 6 group pattern. सर का बना हुआ है नहीं Please give me that group. Yes, I will announce. I announce the groups. Group number 1 is Manish Asudani from Anjuman College, Itar Fatima from Anjuman College, Babita Verma and Shubhalakshmi, and they both are from Vilai. Then group number 2 is Rahul Sukyavanshi, Tabasum Khan Madam, Shabaki Madam, and Niti Madam, Nasa Rehman. Group number 3 is Samta Ramteke from Sankara University, Manipur University. Sheikh Khan from Sankara University, Anil Ban from Amravati University. Group 4 is Patek Madam, Manish Gupta sir, Tiwari sir, Ravi Mishra sir, Meenakshi Madam, Vaishali. Your title, I give you the paper. Title is all our. Anyone else present here? All of God are persons. Check your name. Use a group activity. But you have one can also present.
Hello.
So distribute the papers. Oh, we gave you the research paper today. Yes, sir. Yeah. All the answers are in one group. We have made that way so that you can coordinate among us. Marks are 15 marks. This will be submitted to us. Marks are on presentation, technical knowledge, and question and answer. So all group members can answer even one question. और फिर भी नहीं होता है तो इनको कॉन्ट्रैक्टर and it's two and it's three are different. Combining those two will form the three points are different. All of you have number 2. In that there are 2 points. Point number 1. The first point is key principles practices from the article, that is common. But the second point, application of principles and practices, that each member in your group will write a separate application. There will be name 1, name 2, name 3, name 4. So if there are 6 members, 6 applications will be noted down there from your item. Yes or no? But point number 1 will be solved. This is annexure 2, and annexure 3 is very much clear. It is written identify 3 key learnings from the activity, list 3 key lessons on the topic that is given to you, and also the implementation bullets. In that paper, what implementation is given, and share the implementation plan for your three lessons that you've taken from that paper. When will दिया हुआ implementation और आपका क्या? अगर वही चीज आपको दी गई तो how will you execute? So both elements and three are different. You have to fill both. And your PPT will contain these points. PPT इस पे बना. ये बन गया मतलब PPT बन गई मतलब ये बस. That's your responsibility. Sign हो गया सब पे? Unmarked sign. पेपर दिया कि राजेश सर आपके पास है पेपर? पेपर का दस ये नहीं चाहिए ना आपको? क्या साइज है बार बार पूछ रहे थे.
noise is generated, but gradually when you have gone through this all these epochs, in every epoch the quality of image that is generated is improved. Okay, still here it is not much realistic, but at least you can appreciate that okay, in the direction at least the training is happening. Right, so I can say this number is generated is 5, this one is 3, this one is 5, 9, 9, 4, 8, 0, 8, 1. So likewise, if you go on training more and more data set, then it is going to be more accurate. Okay, because we have limited time and limited number of resources available on Google Colab, so that's why we have executed very few iteration and we have worked on very small data set. Okay. Now problem is with this GAN is it is generating all type of images, right? Because here I cannot say I want to generate image of 7, right? Randomly it is generating either 7, 4, 3, 2, whatever you want to generate. It is not giving right to me what type of image I want to generate. Okay, so out of all these 10 digits, it is not allowing me to specifically generate one digit images. Okay, and if you want to generate those images, we have to modify the GAN to something is called as conditional GAN. Okay, so here we have conditional GAN, and simply we have to modify the architecture of GAN. So this is our earlier GAN where we have the dimensional generator GZ and real image we are going to pass through discriminator. Right? We will modify this GAN with something is called as condition. Right? So what is going to be the condition? Condition is going to be which type of image I want to generate. Right? And here how I am going to modify. So for example, here I want to generate digit 0, digit 1, digit 2 and so on. With respect to specific level, I want to generate specific set of images. Okay, and that is just by modifying the network in this fashion. So you can see here, while passing random noise to the generator, in addition to noise, what I am passing? The corresponding labelers, right? So let's say I pick some random 100 values in that latent space. Then I'll also pass for which dimension, for which particular level generator is generating the output. Right. So corresponding Y label will be passed here and corresponding Y label will be also passed to the discriminator. Right. So in earlier case, the label information was not passed. Okay. And to answer to your morning question, you are saying that if unsupervised learning is there, then we are not going to pass label or not. Okay. So though here it is unsupervised learning is there, but still we are passing the labels. So that doesn't mean that this is supervised learning now, because here I'm not trying to find out the relationship between input and the label. Rather, input as well as label I am passing to the network so that with respect to that label, now generator will be able to generate new images. If I am passing, let's say, only 0, so all the 0 images will be generated by the generator. According to if I change the digit, then it is going to generate those set of images, right? So here you can see this is how it is going to generate the images with respect to specific level, right? Now code is going to be the same exactly that we have seen into this GAN. Only difference is going to be in implementation part with respect to label information. Okay. So for that conditional GAN also I have created this conditional GAN notebook. So you can see here, right? So this, I think this is going to take a lot of time for conditional GAN, but I will tell you where this label information is passed. So this label information also we are adding in the model, right? So Z, that is random vector plus label information we are passing. In earlier case GAN, we were simply passing the input, right? Simply we are going to create here I think more Okay, so if you compare the normal GAN and the conditional GAN, so you can see here I'm not even passing the label information here. So output layer is there 28 by 28, that's it. But if you see in conditional GAN here, I'm passing the label information also to the model. And that way it is going to learn with respect to specific label that specific output will be generated. Right. For example, in human faces we were talking about, let's say I want to generate all the faces of female. Right. Then there are going to be two categories, male and female. So if I pass the category female, all the female images, face images will be generated. If I pass male as a label, then all male images will be generated. So that means in earlier case, GAN, it was generating all type of images at once. But if you want to restrict GAN to generate specific type of image, we are going to pass the label information, and that's what we call it as a conditional GAN. Okay. So again, you can run these models, and you will see at the output it is going to take a lot of time. Okay. So I tried to run it for few epochs, but it was taking more than 1 hour to train that model. Okay, that's why I stopped it. But if time permits, you try to run the same Jupyter notebook in your local environment, or maybe in your free time in the same Colab environment, and you will see the output. Okay, that is conditional GAN. Okay, there is one more. There are many variants of GAN are there, but very interesting one I just want to share with you is this something is called as cycle GAN. Let's see if it's okay. So you can see here it is called as unpaired image to image translation, and you can see here given set of apple images, it can convert into set of oranges. Right. So that means you are going to pass all the images of apples, it is going to convert into oranges. Right. You are going to pass all the images of horses, it is going to convert into zebras. Okay, that is the working of cycle GAN. Okay, so you can see other application is you are passing the, let's say, realistic images, it is going to convert into paintings, or vice versa, you are passing paintings, it is going to convert into realistic images. Okay, so that sort of applications are falls under this again cycle GAN. Okay, so this is all about the generative adversarial networks. Okay, the major component that is missed from by me is mathematical formulation of this GAN. Okay, that is quite we have missed here. Okay, because of time limitations, I could not go through this entire loss function, how to design and how to calculate that loss and everything. But still, once you get the idea, if you know this logistic loss and binary cross entropy, later on you will be able to figure it out by how to combine this both discriminator and generator loss. Okay, so this is all from my side for this generative adversarial networks. All the resources that I already shared with you and important links from where you can understand all these topics easily. So all the Jupyter notebooks as well as the presentation files and the code, everything that I shared in this folder for your reference. You can go through it, and if you have any doubt related to any of these concepts, you can contact me either on LinkedIn or maybe on WhatsApp channel. I'll be able to answer, or at least I'll be able to provide you relevant links so that you'll be able to go through that blogs and you'll be able to understand it quickly. Okay. So that's it from my side. Now, if you have any questions, to let me know. No, conditional GAN For every GAN, the architecture is going to be different, so loss function will be different. No, in cycle GAN, it will be calculated with respect to generated images also. Right. So you once to understand the GAN principle, it is very easy to understand the cycle GAN. Okay. So in cycle GAN, what happens? We have let's say set of images of horses. We are going to create a generator which is going to map it to zebras. Now same zebra images we are going to pass to another generator which is going to convert it into real horses. So horse to zebra, zebra to horse cycle is forming here. Right. So we'll be having there two discriminators and two generators. One is mapping from horse to zebra, another is mapping from zebra to horse. So all these losses we have to combine it. Okay. So discriminator loss will be the same, the cross entropy, but here reconstruction loss will be there. Again mean square because horse to zebra, zebra to horse. Then horse and this horse is supposed to be same. Right? Original horse and the final output that we are getting as a horse, that is supposed to be the same. So that loss will be affected. Okay. This is again all the permutation and combination they are going to do with the all the networks, and they are trying to figure it out new way to learn things. Okay. So that way we can think. Any other way?
Medical point of view, this is constructive technology, but this can, but at the same time, criminals can misuse.
No, criminals, if you provide them technology or not, they will know how to
In
use.
place of orange, you are converting to apple. So in place of honest man, a criminal picture, he was tempted.
No, in that case, I would say the police also need to be very intelligent in that way. Yes. So, now, earlier, if you see the timeline, earlier thieves were there, they used to rob at your home. But now you started digital transactions, now they are stealing from your bank, from banks.
So celebrities, these kinds of attacks are there.
Recently, I don't remember one particular celebrity was suffering from a deep fake. Right, so somebody tried to
Akshay Kumar with his
Akshay
gaming
Kumar, even the what I can say, the Putin, his image, his body, and somebody is trying to make some news, right, by making some statements. Right, people thought that actually Putin is saying that Russian, right? But ultimately, then after some time, they realize that that is generated by deepfake. So chances are there, right? People are getting smarter in that way to do the criminal activities, but at the same time, other population have to be smart to beat them.
Yes, any question from the participant?
Fine. So thank you all. Thank you, ma'am, for giving me this opportunity. Thank you. And also thank you for all the participants for making this session interactive. Okay. So if you have any further queries, feel free to. I'm not the host, right? I'm not the host, right? Can I close the meeting? Yes, sir.
Thank you very much, sir, for the wonderful session. The session is very informative, and we would like to have more sessions in the future also. Thank you very much.
Participants, can you give the feedback for today's event? Anyone, please? Thank you, ma'am.
Thank you very much, sir. I just started the generative AI and your session was very helpful for me. And I got many of the things that I was unaware and got it done. Thank you.
Thank you, ma'am. Yes.
Sir,
Sir, please.
Yes, sir. Regarding that, you have told that in adversarial AI, two neural networks have been working with each other, but both are working for in opposite side. So suppose if we are going to have two neural networks and both are working for the same in the same direction, then it is possible if then the output in that case and the output when they are working in opposite direction. So we will compare that output. So which will be a better option for the
If you see the generative networks by itself are adversarial means if you don't have that adversarial behavior, right, then loss will not be backpropagated. Because if both are running towards the same thing, right, nobody is pulling each other. So it is simply a neural network that is stacked, right? So it is stacked one after another. Because discriminator is able to, or generator is able to fool the discriminator. That's why generator is becoming more intelligent. If they both are working on the same thing, then generator will never become intelligent.
Yeah, okay. If there is bootstrapping between both two networks, it could be possible that if suppose I am just stretching one of the boot, then that another boot will come with. So in that case, if I have that kind of arrangement, what would be the output? Means the efficiency of the neural network will be.
Getting clear.
I am telling you that you have told that in adversarial network there are two networks and both are working in opposite side.
Yes.
Opposite. One is generative and one is destructive. If bootstrapping has been to and one is moving forward and another is also following the previous one. So at that peak what will happen?
No, but if you see, in that sense, you are saying that both are going to do the similar things.
Yes.
Then it is simply the you are having one network and you are stacking another network.
Okay.
One is also the discriminating
Following the first one.
Then it doesn't make sense, right? So both are doing the same thing, so it is simply the discriminating. Both are ultimately trying to do the same thing to classify in that case.
Okay.
Right.
Okay, thank you, sir. Whatever you have told, everything is clear. But I think that probably there is a amount of effort so that you can explain the concept also. Then it could be.
Yeah, I was even hoping that there's going to be a blackboard where I can write some equations and explain.
You have used many concepts like epoch years, but you have not explained all those things because maybe short of the time, but still.
Actually, what I assume that this is quite advanced deep learning session. Right? If I invest epoch and the loss function and everything, that time is not going to be sufficient in order to explain. Okay, so that way, because yesterday I was discussing with the man that whether I have to start from the scratch or do you expect audience already familiar with the system. Ma'am suggested that the audience is supposed to be already familiar with the deep learning because the topic itself is generative AI.
Actually, so that there are so many faculty or participants from the different departments. So I don't think that everyone is known all those topics.
Okay.
But it's still
Okay, what we can do, the topics that I have shared or the resources we have that I have shared, you go through it. Whatever topic you are not able to understand, just make a note of it and just share the topic with me. I'll be guiding you to relevant resources. Okay. That way, but practically, you also know in 6 hours explain all the fundamentals and again touch to the generative. Actually, if you lost 40, 45 minutes in the morning, right? So that was in the mind throughout the day because I wanted to cover all these things. even unfortunately we also miss that mathematical part of generative. Sorry, loss function formulation. But anyway, good thing that you are concerned about that and you are hoping that topics to be covered. In future, we can also have the fundamental topics first, and followed by that we can have this advanced topic.
Thank you, sir. Thank you for your guidance.